Let's go, people. You know, the Thunder tried to... Hey, the Thunder tried to get us. The Thunder tried to get us. But it couldn't. It just didn't have the ability to get us. It did not have it. Fantastic. Let's keep on going. Multiple values. We have one more bug in our implementation. To new web developers, this can come as a shock, but it's actually perfectly valid. Oh, yes. I do. Like, honestly, even after I've written HTTP from scratch on multiple occasions, I forget this, and it's also the devil. Let's see. To have multiple values for a single header, for example, Lane loves Go, Prime loves Zig, TJ loves OCaml, is perfectly valid. That should be the name. That should be the value. Right? Isn't that like just like the devil? Did you know that? You can have headers with multiple values. I am still convinced this is just insane to me. All right, add a test starting with a header that matches a header in the data to be parsed. Update your parse method to check if the header key already exists in the map before inserting it. If it does, append a new value separated by a comma. Let's go. That's why we use the set method, right? That's why we use set methods. So, okay, we're gonna go like this. Name equals, let's go like that. We're gonna paste that bad boy in, and then we gotta go like this. If VOK equals h.headers.name, then we're going to go like this. If okay, right? That's found, right? Yeah. So if it is there, we're going to go h headers name equals format. Let's just go like this. Sprint f, %f, comma, %f. Look at that bad boy. Look at that bad boy. Take the previous one, add in the new value. Else, we're going to take this, put it into here, and we're just going to go name equals value. Yeah? Yes. Yes. Aren't we all happy? Headers. Now, that should be pretty nice for us. Now, let's see. Let's see, update your parse method, add a test. Yes. So, that means I should be able to do the following. I should be able to go like this. Host equals that, and let's just yank that one and paste it in here and go like this. Actually, it can be the same value, right? There's nothing that says it can't be the same value twice, right? Ooh, what a great test this is. Right? Done should be not there, and we should do this. Okay, great test. We never actually tested this condition, did we? Good test. So we should actually see the following. All right, so there we go. Now, they put spaces in here. Now, I can't remember if the RFC requires... Does the RFC require spaces? I actually can't remember if it requires spaces or not. May combine multiple field lines within the field section with the same field name into one field line without changing the semantics of the message by appending each subsequent line value separated by a comma and optional white space, which we're not going to be doing. The order in which the field lines with the same name is received is therefore significant to the interpretation of the field values and must not change. That means, aside from the well-known exception noted below, that must not generate multiple field lines with the same name in the message, whether the header or trailers, or append a field line when the field line of the same name already exists in the message, unless the field's definition allows multiple field line values to be recombined as separated list. At least one alternative to blah, 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 blah. In practice, set cookie header field often appears in a response message across multiple fields. Yeah. So my only question was, does it always just append all the values, or is there any sort of like duplicate header? There we go. The server must not apply a request to the target resource until it received the entire request header section, since later header fields lines might include conditionals, authentication, credentials, or deliberately misleading duplicate header fields that could impact the request processing. Okay, we're just going to assume that this is correct. There we go. And now, of course, before we move on, you already know what we got to do. You know we got to take this. You know we got to do this. You know we got to run that. You know we got to get first try. You know we got to move on. Okay, just to make sure, I actually never really did test this. So if I do that, go test. Let's just make sure that fails. There we go. Good. I just wanted to make sure I'm actually testing things, because technically I could just not have added a test and everything just works. You don't want to lie to yourself. You cheat to yourself. You cheat the forest. You know what I mean? And you do not cheat the forest. Okay, there we go. So we have this assignment. Okay, add to parse. All our test cases, let's say all our tests are passing. Now let's hook it up to the state machine and watch it parse the full set of headers. Back to the request package, we're going to update our request parse method to include header addition. Yep, so that means we're going to need to do some things. We're going to need to definitely jump into here and go all the way up to our state machine states and go, let's yank that one and go to the D and go state headers. And we'll go headers, right? So now we have that bad boy. We can go down to parse, and inside of here, we should have a case for state headers. And we should also have one more. We should also have a default. And that should, let's just go for us for now, go panic. Somehow we have programmed poorly, right? And then let's update this one, state headers. I know this is not like the greatest state machine in the universe, but here we are. We have this one, so now we're kind of ready. We have our state headers, and now we need to keep on doing headers until we are done. Create a new test function. This one will be focusing on parsing headers correctly. Okay, let's do that one. I'm gonna copy this one, go into here, and we're gonna go func test parse headers, and we're gonna go t testing t. Some low T testing, as they call it. Got him. All right, we have this little bad boy, which oh my gosh, Lane. Okay, Lane, we're gonna have a little chat, Lane. Community note. Yeah, you found a problem. Excuse me, sir. The header code in the parse function is producing a header without a get method. Clearly the get method is for lower casing the name value provided. Without this, content length and content length would be two different values. Get your act together. I also love you. There we go. Submit. Just in case he's wondering. Actually, I just want to let you know that actually, rare L lane has been downgraded to uncommon lane L. Uncommon L. I am gonna go like this. I'm gonna take all these little header calls, losers, and I'm gonna go headers, open bracket. Let's go like this. Let's do a little classic people fighting one-eyed Kirby, right? We all know about that fighting one-eyed Kirby. Hit it in here, and I'm gonna go like this. Headers dot get, and just toss that right in. There we go, like that. Classic one-eyed fighting Kirby. You know what I'm talking about, baby boys? All right, there we go. So we have this bad boy. We have the header. So let's go back to our request. Jump into here. You're probably wondering how am I navigating so fast? Because I'm like, oh, hey, I want to go to header tests. Oh, I want to go to request tests. Oh, I want to go to request. Yeah, it's called, guess what, losers? It's called Harpoon. It's great. You wouldn't understand. Headers is going to be headers. Yeah. There we go. We got the little header struct. Let's do this. Again, we're not going for any sort of performance. We are going for just going through a course linearly. We're not really thinking too hard through things. All right, so what do we have here? We have this additional method in which should now grab out these hosts and everything. So we need to properly do this, which means that I need to do the following. I need to go like this. I need to, once I get to here, where's my new request, right? How do I create a request? Request goes like this, so now I'm gonna go like this, headers, and I need to go headers. There we go. I don't like, okay, for whatever reason, this makes me feel real weird. I feel like this needs to be a pointer, don't you? I feel like this needs to be a pointer. I feel like I'm going to run into one of those weird state updating issues that pisses me off and then I hate my life, and so I'm just not going to do anything, okay? So I'm just going to keep it as a pointer. There we go. All right. I've run into a couple issues, and I can't remember them all in Go when you run into them, and so I'm just not going to run into them, you know? All right, so now that we have that, what I'm going to do is I'm going to go like this. I'm going to go n done equals this r.headers.parse, bring back in that data. And that is going to be, where are we at? How do I do this? Switch state, red. Okay, I'm going to go like this. Current data, wrong one. I do not like the song we're listening to either. Data, read. I kind of feel like this is a good thing to do. So at the top of every one of these, that way I can just go like this. Current data, I like it. And then I update the read, I do all that. And then in here, I go like this, current data. And then I'm going to go like this. I'll go down here and I'll go if done. Then I'm going to go like this. R.state goes to the next field, which right now we are doing things very raw doggy. Okay, we are very raw dogging it. If we go like that, how do I do the errors? Okay, the errors, I'll just go like this. 0 okay. Else, n is how much we have parsed, people. So I'm going to go like this. Read plus equals n. Yeah. And if I'm not mistaken, this contains also the length of the headers. It does. Excellent. All right, so we have our read. We have a read as their plus n. We're going to be done. We're going to move on. And that's that. There we go. Okay, looking good. We have our read. Our read is nil. And that's what we're doing. Okay, this is feeling good, people. So I think I got this, okay? I think I got this first try. You know what I mean? Test headers. I think we're going to get that. And we're going to do it 3 bytes at a time. That feels hot. That feels good. That feels ready. I feel ready just to take this bad boy, copy it in, paste it in, don't even look. Okay, I didn't get it. Something happened. Okay, yeah. I totally get that. I don't know what I did wrong. Okay, shoot. People, I somehow got an infinite loop, okay? All right, you know what? The only way I can actually recover from this infinite loop and the embarrassment of ruining something. Hey, Primegen, you should show your promo code at some point. Hashtag marketing. Lane, it's right here. boot.dev/prime. Idiot. So, what happened? My guess is that the thing that's going wrong is this right here. The parse is, my assumption is that parse is probably correct, right? Because if there's no new line, then we don't do anything. Else we parse out the header, and then either we return false, false, or we return all this stuff, and then we go again, we keep on going, and we keep on moving forward. So I don't think it's that. My guess is that it's this thing, it's this state machine right here, that I read an error, right? If it doesn't equal this, we do this. If n equals 0, then we return 0, nil. Right? There's like nothing we can do. Like, hey, we couldn't read anything, but there's also nothing that we need to do. Fix your crap. There we go. That ran it. Okay. It's still not. I lost. Okay, I'm a loser. So what did I do wrong? Let's just go like this. Let's just go test. Let's just test them all. Okay, so what do we get wrong here? Request test line 40. Okay, line 40. 40, oh, right here. Oh, no error. Wait, what's the error? No error? What do you mean? Malformed field line. Wait, what? What's a malformed field line? What, porque, and also Maria? What do you mean, malformed field line, porque Maria? Porque Maria. Wait, hold on. Porque Maria. Okay, so what is actually going wrong here? Because this should not have been a malformed error. I'm a little bit upset about this being a malformed field line, right? Malformed field line should be right here. Malformed field line. Is it malformed field line is saying this one right here? Okay, interesting. So it's saying that I did not get a good parsed header here. Let's go like this, just to make sure I understand what's going on here. Let's just go format, print, f, parse header. Here, can I just use, I prefer slog, honestly. I like slog info, and let's go like this, parse header. Let's go like this, field line, right? And then let's go string field line, right? Yeah, let's do that. There we go. And let's just test this thing out. So where's my problem at? Okay, how come I don't see it? Porque, oh, there it is. I agree. That is a malformed field line. Good answer. Good answer. Hey, good answer. That's a malformed field line. Good answer. Good answer. That's bad. I agree with you because that's not a field line. I think we know what went wrong here. Right? It has nothing to do with this. It has everything to do with this. Okay, so let's walk through our parsing here. So our parsing has read set to 0. We go into here and we go state init, and then we do this one, and then we increase right here. Now up here we do current data is read. Do we do any copying or moving of data? It does not look like we do any sort of copying or moving of data, which is probably the right way to go about doing this. We just sit here and we do this. Okay, so we should hit state headers. And then we should take the current state. Oh my gosh. Is this doing the thing I think it's doing? Is this doing what I'm thinking it's doing? It is? That's insane. I guess it's not that insane. It can't be. I guess it's not that insane. Okay, so it's not doing what I thought it was doing. I thought it was, okay, I thought it matched this state init case, and since I changed state to equal this, it then matched the next case, but I'm like, no, that can't be right. I refuse to believe that. I refuse to literally believe that. I refuse. I still kind of refuse to believe that that's the case. Okay, so what went wrong here? So we do this parse line, we get all this stuff, and everything's looking good. So I'm gonna go like this. Okay, I wanna prove to myself this doesn't actually happen. I'm gonna go like this. Let's use slog again. Slog just feels really nice, you know what I mean? All right, let's go like this. Parse current, let's see, we're gonna do a parse line, right? We're gonna go request parse, and we're gonna have current data, and current data is that thing right there, but we probably want to hit it with a string because it's not really a string. And then I'm going to go in here and I am going to do a little bit of a parse line. We're going to do a little bit of state init, and I'm going to go like this, a state, because now actually I'm curious. Now I actually have no idea if this is true, right? Now I actually have no idea if this is true. Let's go like this, state headers. I just want to see if this does that. All right, so you can see that it's growing. Yeah. That's perfect. So this is where it should happen, right there. Shazam should cut that out. State init. Wait. Yeah, okay, that makes sense. Current data equals this. Then state. Oh my gosh, did I do? What did I do? What did I do here? Wait, how is that possible? I thought my current data was different. I thought my current data was this thing right here. I thought my current data was that right there. What do you mean? All right, so let's look at this thing and go like this. Let's go read. I want to know what read is, okay? Read should be effectively 0, right? Read should be 0 until it's not 0, right? You know what I mean? Now I'm actually curious, right? So read should be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Bam, state headers read equals 16, which is the correct one, which should be this. Yes. Yes, that's correct. State equals headers equals 16, which is good. Then we get that, and then we have this current data equals this. Wait, what has gone wrong here? Because why am I getting this new one? Why am I getting this out? Why am I getting this out? Why am I getting that one out? Okay, now I'm a little bit concerned that I'm somehow not returning things correctly. Am I not returning parse? This is why I like, this is typically like why I like single return statements, because it honestly gets way easier. If you don't do that, it feels really, really confusing, and I always end up hating it. All right, this seems like this is the exact reason why I like only having one exit point, because I always make this mistake. It's so easy. Here. Return 0. State read init equals 0. State read headers equals this one. Hold on. Okay, that's a 0. That should be, this is a /n/add, that should be a 0. Then we find this, and then we have a current data equals ho. That can't be read, but read equals 16. Why aren't we returning? ¿Por qué? And also, Maria, why aren't we returning? Right? Why aren't we returning? See, I hate that kind of stuff. See, you see what I mean? Like this. Oh, okay. It's obviously, okay. Shoot. See, this is why we have to be smarter. It's this thing right here. I'm so stupid. So this is obviously what's happening. Does everyone see what's happening? I returned simply 0 nil. That's stupid of me. This is why you should not do that. It should be break outer because it needs to return the already read data. I'm returning, I'm not reading any data. Super, super simple. I'm the dumb one. I'm the killer. I'm the person in the room that is causing all the problems. Okay, it's as simple as that. We'll jump up here, remove that. There we go. Everything is working. I'm the killer. The killer's in the room, and I happen to be the killer here. All right, do one of these. All right, fantastic. Move on. I'm the dummy. So there we go. This is all looking good. I believe we all have the right stuff. All right, what's the next one? Let's test our request line and header parsing live with the TCP listener. Again, we already did the hard parts. What? Update your application to print the request line to look like this. Request line, header values, header key value, key value, key value, key value, key value. Got it. So we're going to go like this, and then I'm going to go like this. Let's see. Header, key value, key value. Ooh, interesting. How do I get keys out? I don't have that feature yet, right? We don't have a feature to actually iterate over the keys. So how should we design that? Anyone have any plans on this one? This is one I don't actually have a simple plan for. I don't have like a function. I don't have like a headers, right? Like I don't have like a for each, right? Do you for each over it this way? Like how do you do this one? I could create an iterator, but iterator in Go, an iterator in Go is just awful. You know what I mean? Yeah, for each, we're gonna CB func name value string. There you go. I think that should be good, and then I should be able to go slices. Don't they have a for each? Don't they have a? Do you not have a for? What do you have? Do you have anything in here that allows me to do this? Well, it's not a slice. It's not a slice. It's actually a map. It's a maps module, right? And this is, let's see, returns an iterator over the key value pairs from M. Okay, so I can go all, right? So I can go all, then I can go, but I can just go like this, right? I can just go for name value range over h dot headers, right? I can just do this, right? CB name value, right? Because it's an internal thing. I don't want to expose my internals to you, boy. I don't want my internals to get all up in the business here. That's how, I mean, I guess this is one way to do this. I don't know if I love this, but hey, here we are. Here we are. Here we are, right? Here we are, headers for each, func, yes, that thing, and then I'm going to go like this. Yeah, it makes sense. Yeah, it's the thing to do, right? It's like if you have this you know, it's its own set of problems, you know? This is that thing that I always run into, which is like you can spend forever trying to figure out a nice way to make things really work out, or you can just move on, right? We're not trying to, oh yeah, key value. I'm not trying to design the world's greatest interface here. We're just trying to understand how these things work. And so I don't think we need to spend too much time deeply considering how you'd want to do this, right? Whether you'd want keys or not keys, it's just like, meh. Time to just get working. Look at this. Not even do anything. So here, how do we do this? We have to take this one. There we go. All right, we're banging, boys. Boys, we are banging. There we go. We got this one, and there's the headers. Way bar. My way bar is asking over and over again to see if 42069's awake. You can see it right here. It's attempting to see if it's awake. That's why we're getting so many messages. Can I just kill Waybar? P-kill -9 Waybar. There we go. That should prevent all that extra crap from happening. There we go. We're going to have that bad boy. We're going to do this curl. We have no response, so I have to manually kill it. We do that thing. We have that thing working. Murdered, absolutely. Take this bad boy. We're going to grab this bad boy right here, put it in here, and get the pass. Let's go. First try. We got it, boys. First try. Let's go. Let's go. All right, we're going to move on to the next one. There we go, babies. All right, parsing the body. We're almost done parsing the request, which, frankly, is the hardest part of an HTTP server, in my opinion. Well, it's the hardest part of... We got to probably re-say that. It's the hardest part of doing the HTTP protocol, not the server. The server has its own set of problems. Here we go. We're right here. So now all we have to do is current code parses the start line, the field line, the extra registered nurse in between. Now let's tackle the message body, but beware of the edge cases. Yes, lots of edge cases. According to this RFC at 8.6, the user agent should send content length in the request. And should has a specific meaning in RFCs per RFC 2119. This word or the adjective recommended mean that there may exist a valid reasons in particular circumstances to ignore a particular item, but the full implications must be understood and carefully weighed before choosing a different course. All this to say, for our implementation, we're going to assume that if there is no content length header, there is no body present. Good answer. This is a safe assumption for our purposes, though it might not be true in all cases in the wild. I mean, technically, we addendum this thing when we do chunked encoding. In the request package, update your request parse method to parse the body in addition to the request line. Add.body field to the request struct. It should be in the byte right here. This is where we'll store the raw body's bytes. All right, let's do that. Okay, func, test, parse, body. Let's go. T, testing, T, here, put it in. Align this bad boy. So now that we have that, we have this thing right here. We have content length 13. We have that one. That is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, there we go. Got it. Okay, bytes to read, 3. There we go. There we go. We're going to have a body. A body should just probably be a set of bytes. Okay, fantastic. We're going to have this one, partial content length 20. Reader equals this one. What is the error that we're expecting here? Content length 20. What's the problem? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Yeah, this is still a weird test case, and I'm still a little bit unsure if this is a good test case. And what I mean by that is that the thing that's bizarre about this is that if a connection is terminated, meaning we get an end of file before we've read all the data, what is the appropriate response? Right now, we do return an error, but I'm just curious what like the actual appropriate response should be. I don't have a good answer to this one right now. I'd have to think more about it and probably just review what other people have done, right? Bad request. But you can't do a bad request. The connection's already been closed. I can't send back a 400 if it's already broken, right? That's the confusing part, right? Like, do you execute the request if the connection is closed, or do you not process the request at all? Right? It's a lot of questions. It's just a lot of like design questions. I don't know. I actually don't know. All right. So now we need a new thing. We need to have a, let's go up here and let's have one of these, FD, CW, whoopsies, CW. Let's have state body, I like your body. Let's go in here and go to state headers, go down here, go to case done, do one of these, go to state headers, FHD, that body, there we go. We're in here, we're looking good. And now we're gonna parse the body out, okay? So how do we know how much body to parse out? It actually should be pretty straightforward. We should be able to have content length equals, I'm just gonna call it, length. Length is going to be, length stir is gonna be this. Actually, let's just go like this. Let's add a convenience function somewhere up here. Which is going to go, where should we put this? Where should we put this bad boy? Func get int header, right? Get int header, right? And it's going to be headers, name string, right? I just want to get int off of the headers. Maybe we should do this differently, and then we should go like this: default value int. There we go. All right, so I'll go like this: value equals headers dot get. You know, I think I could also change how this works. Maybe it would be better to also include a boolean. You know what I mean? To say like, hey, this thing doesn't actually exist, right? Right? Maybe that's like the better way to go about that. What do you think? I think that kind of is a better way to go about that, right? I think that would honestly, like, personally, I think that's a better interface anyways. Just as like a thing, you know, just as a thing. Exists, there we go. If not exists, that's going to break a test though. Return a default value, there we go. Else we're going to go like this, value string, and then we'll go value equals, actually, do we have to do an I can't remember. Stir conver, right? Stir conver dot a to I, does a to I? Yeah, there we go, a to I. And then we can just go value string, and that has that. If error, we'll just return default value, else return value, right? There we go. Right, so our default value will be 0, meaning that if there's nothing there, then we're good to go. Let's go back to here, go down to state body, go into here, length equals that, get int r.headers, and then, ooh, that's a terrible interface. We'll do one of those. Go on in here, put in a name right there, there we go. There we go, and we're gonna go like this, content length, and there we go. Let's go, if length, whoopsies. If length equals 0, then we'll just simply go like this. r.state equals state done. There we go. Right, we're done. There's nothing we need to do. But if there is something we need to we now need to parse out the body, which is kind of an interesting problem, I would say. I would say, this is how I would look at it, is I would go like this. There's a couple different ways we could do this. One way I could do this is that every time we get data in, I could just append it to the body until we make it there. Or B, I could say, hey, I parsed nothing until I can parse the entire body. So who should be the responsible party for aggregating the data? For the sake of this one, I think that it's probably, aren't servers by definition stateless? No. By definition, they're not stateless. HTTP is supposed to be a stateless protocol, but servers themselves are not stateless, right? Super simple. You count how many requests come in, right? But HTTP itself is supposed to be stateless, if I have that correct. I can't remember. I can't remember if there's supposed to be some sort of state. I don't think there's any state added to this. You have conditionals and all sorts of stuff you can perform on an HTTP request. Anyways, okay, so now we have the body. So let's just go like this. What I'm going to do is I'm just going to keep this pretty simple. New request. All right, don't I have a new request? Do I not have a new request? Oh, I have new request. That's what it is. I'm going to go like this. Body, empty string, right? I'm going to jump up here, and I'm going to go body, string. I'm going to go 7 up here, delete that one, because that's obviously me being stupid. Right? We can all agree. Bro's dumb. Bro's real dumb. I'll go like this. Okay, so if we have that, I will now go like this. Remaining equals is going to equal, how do we want to do this? How much data should we take? Let's go like this. Let's go length, r.body, right? Length minus this length. That's how much we should get. Okay, so if I already have some data in the body, we'll aggregate on the body just to make this simple. And that means if, I'll go like this, then I will go, how do we want to do this? I just want to make sure we get the right amount. Okay, we'll go like this, remaining equals this. I'll go r.body plus equals. I know this is really gross, but just deal with it. You know, current data up to remaining. There we go. So we're going to do that up to remaining data. That's how much we should be grabbing out. And then we'll go like this. Then we'll go a minimum of this or the length of current data. That should be pretty obvious what's happening here, because you could imagine you could have more data afterwards. You could maybe have a second request ready to be queued up coming in. I don't know how exactly that would all work in your server, but you could imagine you could have more stuff. All right, let's go back in. We're going back in, people. Wouldn't it be up to the length of the current data? No, it's up to the length of the content length that is remaining. So we're either going to have the amount we need left or the amount of current data that is remaining. Then we're going to take this and we will simply say, hey, get the remaining right there. And then I'm going to go like this. If length of r.body equals length, well, guess what? r.state goes to the next field. State.done. There we go. And then we should take the amount of data we've read, which should be the remaining amount of data, which is going to be read plus equals remaining. There we go, because this is going to be important during trailers. Trailers, remember, that's a thing. Don't forget, trailers are a thing, people. All right, there we go. This is all looking very, very good. I think this should just work because, you know, first try, that's who I am. So this is our new test right here that's doing this, which should be partial content and that content, which I think is the right thing. And if we do a read from this, how does a read work? Read is on the outside. A read should happen right here, which is if we get an answer. So this is where I have the to-do, right? If there's an end of file, we have like an unexpected thing crashing. So we're just going to say, it's just an error no matter what. Your connection should not be closed. This is looking good. As someone on the sysadmin side of things, rather than the programming side, watching a code, this is downright surreal. Is it weird that I'm not even, imagine not using AI in the Lord's year 2025? Is it strange that someone could actually remember an entire programming language? And a handful of APIs? Isn't that like a funny world we now live in, where remembering how to like write a for statement with your hands and what functions exist on the standard library is now like, oh, dude, that's not good. That's like, obviously you're not trying. It's just like, how is this? How is the world? How has this happened? All right, so there we go. We have this beautiful boy right here remaining. We do all the parsing. We get it all done, and we're going to call it a day. So this is lovely. Let's just call this good. I like everything that I think I'm seeing here. Did I actually get this all in here? There's the partial content. There's the full content. Now, let's go. Do we make it? Do we get it? First try, and not a first try. Dang it. Man, okay, the first tries are definitely on the way down. First tries are definitely on the way down right now, okay? Let's go like this. First tries, not looking good. All right, what happened here? Hold on, okay, hold on. I'm actually a little bit confused as to what is the problem here. Okay, hold on. What was the problem here? What are they saying here? Okay, hold on. What is happening here? Internal headers test 17. Oh my gosh, I feel cheated. I want you to know this right now. I am cheated. You are cheated. We are cheated right now. We've been cheated here, okay? 2021. Oh, no. What's the last one? I already have this written right here. Where's the true? All right, what's your problem here? Wait, did I already define host? Oh, I did define host. All right, there we go. Yep, okay. Same problem here. Dang it, dude, look at what I got owned by. I just want you guys to know this right now. I got owned in the stupidest possible way from not first trying that. All right, let's go back to this one. Let's grab these ones. Actually, let's just go like this. I'm going to grab all of this, right? And then I'm going to jump back to here, and I can go like this. We're going to go into here, and we're going to go r/headers, yeah. Let's take out that. Let's put that bad boy in. And we got this one. What are we doing here? Oh, wow. I mistyped that twice in the same way. That's insane. I just mistyped that twice the same way. Acceptant. Dude, that's crazy. I got to learn to type better. All right. Did I really just... Okay, good. Okay, good. It's not me owning myself. This is good. All right, so good. I actually do have a problem 102. So they're claiming that this is a problem. Okay, good. So I must have done one thing wrong, which I feel like I can call, is right here in state headers. I'm saying it's done. No, it's body, people. All right, interesting. What happened here? All right, so we have headers test 26. Okay, what happened in headers test 26? All right, that should be a false. No, that should be, wait, what? This should be missing header, right? Or missing, I think I had it as missing key. So everything's good, but now look, we are now freezing on the other one because I have some sort of infinite parse. Oh, shit, right? That's what's happening. And for whatever reason, I think I know there's like a problem going on here, is that if I look at this thing, why am I not returning this? I should be getting an this, right? When I read, I should be getting an end of file error, and if I get an end of file error, that should be something that says like, hey, you done effed up. You done effed up. You done effed up. You done effed up. You done effed up, right? So let's find out what am I doing wrong here, because my guess is that I'm not doing this part correct, right? You know what I mean? I'm not doing that part correct. So let's go like this. Let's go like this. Let's go format, print. Actually, you know me. I'm a slog boy. Okay, I'm a slog boy. You know I love that. Parse state body, and let's go like this. Remaining, yes. And then we go body. Let's do r dot body, and then let's go read. Let's go read, and then I'm going to take this one. I'm going to actually jump over to here, and I'm going to put it in there because honestly, little nicer. You know what I mean? It's a little nicer having it right there because the body could be long. And then, okay, good. That's what I thought. So look at that. Read 3, remaining this, and then we can't seem to go forward. What am I doing wrong here? I have a missing condition, people. I have a missing condition, which my condition, the condition of my life. If, okay, watch this one. Here we go. If length of current data equals 0, then break. We can technically break outer just to make sure that always remains clear, but break should break on the outer. And if I do that, that should give us, okay, that's what I thought. Okay, so we can see that we're doing hello world. You can see that we get that all parsed out. Then we do hello part. This one, that one's not parsing it out. You know what I mean? Outer dance. GC, yes. Break dance, boys. Boys, we break dancing. All right, I like that. It makes me feel better anyways. It is way better. If I'm going to use labels, I'm going to use dance. Dude, I didn't even think about that. That way I can at least smile when I'm making a horrible decision. You know what I mean? That does make me happier. Okay, so what have I done wrong here? Oh, what was the problem? All right, unexpected error, end of file, really? Oh, really? Request 42. I mean, in some sense, yes, this is true. Like when we hit an end of file, it is really a problem here, right? I kind of feel like this is a bad test design this thing. I don't know. Hold on, let me think about how would I want this, because this should, I mean, I see why this is breaking, right? Okay, so this is why, if I'm not mistaken, I think I understand why this thing is breaking, in the sense that if I go here, let's just, oh my gosh, who did that? Who did that? Who did that guy? Who did that guy? Why would you have that in there? Okay, so that's not the way I want it. That's fine. Let's go like this. Let's go like that. There we go. Okay, so that should just do that breaking one. Okay, so I'm actually curious, how would I prevent this, right? Because what's happening is I get to here, I get to the content length, but the length never gets executed. And why does the length never get executed? That's because on the outside, what is actually happening here? I tried to read the buffer. The buffer is actually getting nothing left. Let's just see what happens here. I'm going to go like this. I'm going to go slog.info.request from reader, and I'm going to go state. I just want to see what the state is. Does that make sense? State. Before equals this, FRR that, paste that in, and then let's paste that right here, and then let's go. No, let's actually not do it before. Yeah, let's not do it before because I'm going to kind of bottom out of my error. All right, so you can see we do a bunch of inits because we're parsing that line. Then we do a bunch of header parses because we're getting them one at a time. Then we hit them with the body parse. And the body parse goes, okay, we're now into body, but we're also completely out of data. So I guess what I could do, I mean, to prevent this, okay, so now we're actually coding around a test, which is kind of annoying. This is one of those things that's really annoying because I'm actually coding around a test as opposed to coding around something that could actually happen. So there's a couple ways around this. Edge cases, exactly. So one way I could do this is instead of setting just state straight to body, right? Because this is where our contention is. We actually transition to body, but we've ran out of data, so the next time we go to read, it says, hey, we're at the end of the file, and it closes our fake connection, which thus means we actually get 0 data back out. And if I go into here, right, we do this whole thing. So I guess what I could do just to make, I mean, man, how do I want to do this? Let's just see if I do that, right? Because, I mean, that's how I would think I'd want to, I mean, this is just one way to possibly do it, but then I think, yeah, we're frozen, because we never actually hit the end. I know why that's happening. That also makes perfect sense. The reason why that's happening is you go right into here, and this always hits 0. We're always breakdancing. So maybe that's not the way we want to do this. Damn, this is a great weird edge case. I'm trying to figure out how to solve this without making it feel unrealistic, right? Because you want something that actually performs more in the realism of it all, because when there is an end of file, it is actually an error, right? It's actually an error, and this should error out. So let's keep that. Let's keep that bad boy, right? We're going to keep dance. Let's keep that. So one way we could get around this, honestly, is by just putting a little bit of extra space there. I really do hate that. Okay, because this breaks at line 42. So this should break further than line 42. Now it goes to 52 or whatever, because it's right here. Like, I really don't like that. That will effectively move the thing forward. What lesson are we even on? Wags Lane, we are on this one where we're parsing the body. There's a bit of an oddity, Lane, that I think that maybe we didn't think through too well through this course, which is when you receive an end of file, it should result in an error. Meaning that a request from reader really should be broken if you get a request, but the request ends in an end of file, because that means the connection theoretically has been terminated, which means that you can't handle this request the normal way you would handle the request. And so there's like this whole problem. And so right now I'm getting around that by adding a singular singular space at the end of each one of these, which it just feels kind of, that does feel a bit hacky. I think we can all agree that feels hacky, but I think I'm right. Like, how would you do this, right? Can you walk through the Git course on boot.dev without subscribing? Yeah, but you just get no interactive features. So that's the hard part about doing this correctly, Lane. I have to change how I'd want to code. Okay, so this is how I'm going to do it. I could technically make this work out and change how I programmed something, which is not necessarily the way I'd want to do this, because I just find it easier to do this. But what I could do is that in headers, I only switch to state body if we'll go like this. Func R request has body bool, right? I have a little boolean in here. And then what I'm going to do is I'm going to go into here and I'm going to yank that bad boy out. And I'm going to go like this. Return length equals 0. Obviously, I'll do a little to do here. To do when doing chunked encoding, update this method, right? Pretty easily done. There we go. So that means my state body, I'll go like this. If r dot has body, well, then we're going to do state body. Else, we'll go like this. r.state equals state done, right? Not what I want to do, but I think this is probably the way to do it, because then I don't have to do this whole check, right? Because well, we do have to do this check because I have to, like, to do, here. Panic, let's see, what is it called? Chunked, not implemented. There we go. There we go. That way I don't accidentally do anything. I believe that should also give me the correct stuff. There we go. Okay, good. All right, fantastic. I think this might be correct. All right, unexpected error. Received this one, but porque also Maria, right? So how did I land on that one? Let's just think for a second, because this one should not happen. We should not receive that as an error. If I've programmed this correctly, which should be 48, should be this one right here. Wait, hold on. Okay, hold on. It's line 42. I was like, wait, 48. All right, so there we go. So it's saying that that is one, but it shouldn't be one, because if I'm not mistaken, I can jump to here and I can go like this, state headers, and I'm going to go like this, slog info. Let's see, parse headers. Oh my gosh. Why are you doing that? Why are you doing that? Parse headers ending. And so let's go like this. We have an ending right here. And I have, see, has a body, r dot has a body. Wait, what is my has body? Is that, oh. Oh my gosh. Dude, stop being, okay, stop that. Okay, sometimes being a logic wizard does not always wizard in the right way, okay? A wizard arrives precisely when he means to, okay? I just want you to know that a couple streams ago. AR, the only reason why I'm hand-rolling slog statements right now is so that I don't use AI to code this, because that would be way too easy, and I don't want to do that. I'm not going to do that for you guys. I'm doing it for you. I'm not doing it for somebody else. I love Gandalf. Oh, you love the Gandalf. All right, there we go. No, fail is just one. It's per lesson. Did we fail the lesson or did we not? I already +1 the lesson fail. All right, so I'm going to call this good, even though, you know, really, I don't like this, and this is why. In the real world, we would not get an EOF after reading data. Therefore, we would nicely transition to body, which would allow us to then transition to done. but I am doing the transition here. Wait, it's kind of like, have you ever done recursion? It's kind of like doing the base case checking in the body. It's like I'm doing base case checking in the botting, and so just like personally as programming-wise, it pisses me off, if that makes sense. Isn't there, it's because the solution doesn't return error if the number of bytes reaches the content length size. Allows for, seems reasonable, I think. No, end of file is always an error, Lane. Lane, you cannot have an end of file on a request response model. What do you do? Like, should you ever process a request in which the connection gets obliterated before you have a chance to even touch it? Something tells me that I would have to think way more about how a server should interact with it, right? That's a very different experience. And so I don't have a solid answer, though. You do, though. You might have an early EOF. And if you do have an early EOF, you should handle the error condition of this, which is what I'm doing. I'm erroring. I know normally EOF is not blowing up. I'm erroring. But our tests are not doing that. Where do you, let's see, where do you respond if the connection is terminated? Exactly. That's what I'm doing, is I'm actually properly saying, hey, there was an error because we have an end of file. Here, handle the end of file error. Right? So I actually think I'm doing the right thing here, which is end of file, here you go. You deal with it on the outside, because this is just parsing. Right? Just like, I don't know what to do with that. You think of how you want to handle this thing. Do you want to process it still? Do you not want to process it? What do you want to do, girl? Girl, tell me your feelings. All right? All right. So I'm just going to move on. I'm going to say I'm right, and we're going to keep it there. Live body. It's finally time to end-to-end test our full HTTP request parsing assignment. Again, we already did the hard parts. Update your application request line headers to do this one. Body, body, string. Okay. Be sure to stringify the body for printing. Run your TCP listener. Do all this one. Okay, we can totally get that one. Let's go like this. We're going to go to our main. We're going to go here, and we're going to go here, and we're going to do this one, and we're going to jump here, and we're going to go like this. We're going to have body, body, string. We're going to go here, and we're going to go like this. Body. Wait, is it all capital B body? No, it's not. Body, there we go. And then we're going to go here, and we're going to go %s, a new line, and we're going to go, where is it? It should be r.body. Oh, yeah. There we go. There's your body buddy. And we're going to do this bad boy. We're going to take this one right here, and we're going to go to here, and we're going to paste that one in. There we go. We're botting. We're going to go body this bad boy. We're going to go here. Damn it, Bobby. Then we're going to take that one in. There we go. We have this nice thing. There's our body. We're going to cut that thing out. Look at that nicely parsed body. We're going to take this one. We're going to take it out here. We're going to run it. We're going to pass it. We got it. First try. Let's go. Okay. Real world, you'd have content length or chunked headers. Correct. Real world, also, your connection, if it terminated, you'd handle an error condition, which is what I'm doing. I'm providing the error conditioning. This is just kind of like a... I understand. I wrote this, okay? This is my fault, so I don't like what I did. I'm just saying I should think more about that. Let's take a look at the struct we've been parsing so far. Request, okay. Now compared to the request, let's see, to HTTP request struct. Now compared to the official Golang HTTP request struct, right? You see there's a few differences. We have a request line struct, while they have elevated the method, target, and version into their own top-level fields. It's basically the same data, but the layout is a bit different. We have header struct. They named their header. Again, which is funny that it's header. Header is like a little bit goofy. I think it should be headers. Okay, because it's actually 0 or more headers. 0 is plural. Idiot. Again, the same data, slightly different layout and naming. I prefer to call them headers because that's usually how web developers refer to them. The Go standard lib refers to the entire collection of field lines as header, but I digress. Yeah, that's just strange. I think we can all agree the word header is incorrect. Can we all agree that header is incorrect? Type 1 in chat if you think header is incorrect. I think I'm correct. I think headers is correct. I think header is just not correct. Rare go L. Hey, go get some L's in there, okay? Can the course be updated? The course can never be updated. It's forever stuck in time. It's on the blockchain. You wouldn't understand. It's not on the blockchain, and yes, it can be updated. The most important difference is we have body field that stores the entire body as a byte array in memory, while the standard Go lib has read closer. Yes, so they do a reader, which I actually still think even their headers, I don't know how headers work, but I think headers should be done with the reader as well, right? I actually think you should have headers as a reader, and I think you should have body as a reader. I actually think having it as an object is incorrect. If you're really trying to get like maximal performance, because once you parse that first line, you can call your handler to go on. And your handler, if it needs access to the headers, can then do the proper weighting and doing whatever. The most important difference, we have a body field that, yep, blah, 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 blah. Our solution is perhaps simpler, but it's more limiting to the users of our library. We force them to load the entire body into memory before interacting with it. The Go standard library allows the user to read the body in chunks or even stream it to a file, which is often necessary for larger bodies. More on this later. Yes, I also don't have a problem with, like, if you're just building something to understand it, taking the easier path, I think, is way more superior than worrying about every possible usability interface until you understand the problem in its completeness. How does the Go request handle bodies different? It streams it with an IO closer. Yep, that's what we're doing. It has no headers. It does not store the body at all. Requires, okay, that top one. There we go. All right, congratulations. You made an HTTP request parser, and honestly, that's the hardest part of this course, but the course, well, we are not done yet. Let's build the actual server interface that handles the request and sends the responses. Now, whether you're getting your data from YouTube or Twitter, every single server has implemented the HTTP protocol, which, remember, is on top of TCP. Though that technically may be a lie. With HTTP 3, it's actually on top of UDP, which actually implements a form of TCP on top of UDP. Now, not all the implementations of HTTP are perfectly identical. If you go off and you peruse some of the horror stories, there's like these very little things that didn't work out. I can think of one time at Netflix in 2016 in which I actually got hit with a bug because, guess what? Headers were being parsed case sensitive, not case insensitive, on a specific TV. Not every implementation is equal. But if you were to implement a server now and say you used Go, you could use something called the HTTP package. It's already available. You could start TCP servers or you could start UDP servers in Go. You don't have to implement these because at some point, somebody implemented all of this and put this into the standard library. If you were to use Rust, you'd actually have to use Cargo to be able to install an HTTP server, but Rust does have a TCP server. Every single time, somebody has to implement it at some point, and we have a specification to hopefully make sure every implementation is the same. Headers, they should be case insensitive. The status line should look a certain way. If you've broken any of these rules, hopefully you're getting back a 400, a bad request. The basic life cycle of any HTTP request usually comes from the client. Now, this client will send off something called a request. Now, this is just a subform of the HTTP message specified in the HTTP specification. There's a lot of specification I just said there. And this usually will consist of what is called a status line, field lines, and a optional body. It can also include trailers at the end. Trailers are just simply headers, but they're computed at the end. You can think about this when it comes to, say, really large file uploads. We don't know how big this file is going to be, but we're going to send you a bunch of data, and at the end, we want to send you, say, a checksum. That checksum needs to be dynamically computed, so therefore that checksum won't be known until the end, so we will have a trailer at the end of the request. So now every single request is going to go across the wired. It's probably going to be passed through many different implementations because every single connection along the way is going to be forwarding the request on to the final destination, the server. And when the connection gets to the server, it's going to parse out the status line. That status line is going to say, hey, here's where it needs to be routed within the server. It's then going to go from there and make sure that it has everything parsed, the query parameters, all the stuff that your server does. And then you're able to go off to, say, the database and get any information you want, maybe go out to a third-party service, maybe even call good old-fashioned ChatGPT to get a response back, and then you're going to send that back with what is called a response message. The response message is going to be identical shaped as a request message. You're going to have a response line, you're going to have field lines, and you're going to have an optional body, and of course, an optional trailer at the end. Trailers obviously for chunked encoding. This is the request response model of HTTP. Notice that in TCP, there is no request response model. It is simply forming data and being able to have that same shaped data be both on the client and on the server. There's no kind of responsibility of the server now to respond to something. Whereas with HTTP, it's also implementing a behavior on top saying, hey, when I do a request, I expect back a response. The response should have status codes that kind of indicate if it was successful or not. That's why often you'll see something called a 200 status code. That just simply means, okay, That was good. I believe it's literally called status okay. A 400 is simply just a bad request. Maybe you didn't provide the right information for the request. A 404, which we've all seen, is simply means that, hey, not found. We couldn't find it. So every single response comes back with more than just simply the information you're looking for, but also the status about the information. Obviously, not every single language is going to be great for the request response model. If you take something like Node, if you have a high compute task in a JavaScript environment, since JavaScript is only single threaded, you could actually greatly affect your request response per second. Typically, though, most people's handlers are actually pretty thin, and it's just a series of grabbing a bunch of data from some external sources and then taking that data, putting it into some sort of formed object, and then sending it down to the client. So they're very, very light, barely affecting the RPS itself. So we're going to have something that's going to be pretty straightforward. We're going to just build a very simple server. I like how Bun did it, right? You just say serve, port, this, and then you get this out. I know we could build like a whole routing mechanism and a string parsing mechanism and a path and capturing values and all that, but that's just way outside the course. And honestly, it is just completely different. So there we go. So we're going to just do it kind of like, we're going to do the bun style, right? So I just want to do serve, port, fetch. Okay. So it's fairly similar to Go's HTTP listener serve, right? There we go. Server, address, handler. There we go. Boom. Listen and serve. We're going to follow a similar pattern with a few differences that I'll point out as we go. In this, by the way, at this point in the course, I can't remember what I did. So this is like the first time I'm doing it, right? To quote the famous philosopher Foreigner, it feels like the first time. All right, in this step, we'll be upgrading from TCP listener to an actual HTTP server. It will accept valid requests and send valid responses. That said, for now, no matter what request is sent, the response is always the same. All right, create a new main.go and HTTP server. Let's go. Jump into here. HTTP server. Let's go. We're going to jump into here. We're going to go main.go. We did that. We're going to go package.main. We're going to go func.main. We're going to go func yo mom. We're going to go func soul brother. There we go. Dogfooding your own course. Reading my own code. I know, dude. Reading my own code is one of the most painful activities known to man. Reading code that's over 3 months old is just. It's like a masochism, really. It's like a big old chunk of masochistic love. Don't be talking about Mop Joe Mama. Factual pain. Yeah, it is. It's a factual pain source. I either get so turned on by my own code, my own old code, or disgusted. No, dude, I know. There is every now and then I see some of my old code and I go, that's the greatest code ever written to man. And then other times I look at it and I go, I hate it. That's why you comment your code. Commenting has nothing to do with it. There's there's nothing I could do with a comment, right? It still grows. Not liking your code, I think, is a sign of somebody who always wants to improve. Technical debt is every line of code I've ever written that's older than 4 seconds. Everything that I've written that I quit looking at is old, right? It's old and it's bad. All right, we're going to create a new one of these. Create a server package in the internal directory. Well, let's go. Let's go internals. So I'm going to go like this. We're going to go here, and I'm going to go like this. Server, and now let's go server.go, and we're going to go package server, and then I don't know what to do from there. So how should we do this one, by the way? I'm going to drop request test and header test and just have this. And let's move this guy up to here. There we go. That looks good. All right, here we go. Create the new main thing. Create a new server package in the internal. Do this one. Copy and paste this command into the follow. There we go. We got this one right in here. So I'm going to go like this. Main right in here, HTTP. And let's add that one, and let's put that one at the tippity top. There we go. All right, so we have a server. Let's go like that. Let's go. So we have a serve port. We're going to have a log. We're going to defer a close. Okay. This is kind of weird. Weird. I'm going to go like this. There we go. We're going to have a little OS with a sigchan syscall to make sure that we can do that. There we go. Server shut down gracefully. There we go. All right, so I like everything that we have here. So I need to have this thing called serve port, but there's still a bit of a problem here, unless if we're going to be doing something a little bit different. All right, so I have no idea what exactly they want me to build here. All right, as you can see, we have a serve function. This is where all the magic happens. It accepts ports and starts handling requests that come in. In a future step, we'll allow it to accept a handler function, but for now, we're going to hard code the response. Nice. Notice the sigchan code. Dude, what a sig chad. And this is a common pattern for Go to gracefully shut down the server because server.server returns immediately. It handles the request in the background Go routines. If we exit main, immediately the server will just drop. If we want to wait for a signal like Control-C, we can stop. In your new server package, we're going to have a server struct. Yep, we're going to have port int. Okay, so we're going to have to go, let's just jump over here and go type server struct. Bam, I don't know what it's going to be. And we're going to have func new, wait, how do we do it? We just have like serve, right? And that's going to be port uint 16, technically. And that should return a server or an error, right? Yeah. What's the other thing that we need in here? It's a close function. That's right. Function s server close. That should have an error if we want to be a proper closer. I'm just going to return nil for now. Okay, return server. Bam, bam, bam. Nil. There we go. All right. Server equals this. All right, here we'll go like this. There we go. Run the server in the background. This will do the whole like creating up the TCP port. Let's go like this. Let's go error. I guess, I mean, we could technically do this one and go error right in here, and then this thing actually has to go. This has the whole go funct code in here, and we'll go like this. Listener equals this, equals net. This is my guess is what we need to do. I'm just riffing right now, right? We're just riffing TCP, and then let's go port. Let's go format sprint f. We're just a riffing. %d. Let's do that bad boy. Port pont. Pont. If there's an error, we'll return out the error. There we go. There we go. We're going to return out the error. Else we'll do a listener. We'll return nil. And then in the listener, we'll go like this. And we'll go con equals this. Listener.accept. There we go. If let's see, equals or does not equal nil. Hey, thank you for that. I appreciate that. We'll just return, right? Else we're going to do something with the con. And so I kind of like this idea of taking this guy. I kind of like the idea of putting this guy right here. You know, we do a little bit of that. We're going to do a little bit of that. We're going to run a little bit of that. And then I can go like this. I can just go run that server, go run that son of a bitch. You know what I mean? It's like, it kind of feels a little bit nicer to go do that. And then I can go like this, nil, do that one, hit it right there, hit that bad boy right here, and then do the other way around. Yeah. And do a little listener on that one. Maybe I like this one better. Hey, maybe I like this one a little bit better. Net.listener, right? Do we do a little listener right there? Listener, there we go. I could accept this because it then just reduces a lot of the fluff. You know what I mean? There we go. See? Okay, I like that a little bit better. It makes things a little bit top down. Makes me feel better about my life. So now that we have this con, what are we going to do here? Run connection. All right, there we go. We have a con, which is going to be an IO read closer, really, if you think about it. There we go. Go like this. Go run connection, con. There we go. So now we can actually handle multiple requests running at any one point. Feels kind of good. I kind of like where this is going. It's kind of weird. I find myself programming more like I'm doing Elixir here, but hey, what can you do? Instead of putting functions on server, we're just doing this. All right. Okay. Oh, nice. Okay, you just do this bad boy. Okay, so you want to do that. Okay, that's fine. Yeah, see, there's a bit of a problem here that you'd have to, like, go through, right? So I can go like this, closed equals true. This is kind of that weird part, you know, like, is this something I want to do? I don't even know. Is this good? Close equals false, right? And then we could technically go like this, if s.closed. Then we could just return, right? Stop listening afterwards. But once it goes to here, like, there's nothing I can do. It just sits there and does stuff, right? I don't know, right? Well, what else do you do, right? And then there's also, like, if you're reading from connections, you're going to also have to do some stuff. So it's a little bit weird. It's a little bit weird. Weird, but whatever. Well, I'm typing in that. Okay. Let's just pretend I've done all these things. Okay, handle, connection net. Okay, so we've kind of come up with something pretty similar here. We'll do a little bit of serve, we'll do a little bit of close, we'll do these kind of things. All right, I think I'm right on here. I think I generally like this. That's what we need to respond with. Okay, so handles, let's see, a single connection by writing the following response and then closing the connection. Let's go. All right, so I'll go like this. You see that? I almost sent nurse registered, not registered nurses. Almost messed that bad boy up. You know what I'm talking about? Okay, almost met the right. Let's go like this. We have a right. We have a right read. Is it a read write closer? Read write closer. What am I doing? Sorry, I can't even think. All right. So we got all these things. So let's see. We're going to do a little curl localhost into this temp server. We're going to do a little bit of this. We're going to cat this bad boy out. We're going to do a little bit of a curl. We're going to get those things out, and we're going to respond. Okay, so let's see what happens right here. I am actually curious if this is going to work. Okay, jump in here. We have these things, and then we're going to do that. And so if I've done this all correctly, and I go run, command, that one, it should just run. Okay, it's running. We're running. So now let's go here. We're going to copy this thing out, and then we're going to jump back here. We're going to go like this. Let's go. First try, boys and girls. First try. Give me that confetti. No one was ready for me to first try that one. You guys thought I was just out of control. You just were not ready for that one. All right, this is what vibe coding looks like. Let's take another look at our hard-coded HTTP response we sent back as this one. This is technically a valid HTTP message, but something is missing. That RFC says include the content length. True. So curl has this thing where if it receives a request and it closes the connection, it just assumes that's the body. Right? That's like a part of curl that does this little like, it just does this thing where it's just like, close enough. Close enough. Close enough. So there we go. We got all these things for messages that do not include content length, field values, providing the framing information necessary, determining whether the data of the message is and. That's right. Technically, this is technically a valid HTTP message, but it's missing something. The RFC is to include this content length. Yes, I believe if the but to see what I mean, go ahead and curl your server again using the verbose flag. You'll read the error messages that is printed out. Answer the answer the question. Okay, let's do that again. Let's see. I still have that bad boy running. Let's go curl. How do we do the curl? Let's go like that. Let's hit him. There we go. Look at this bad boy. Receive failure. Connection reset by peer. Closing connection. No chunk, no close, no size. Assumed close to signal end. Right? So I just close it. And so it's going to say, hey, here's what I got. I don't know. Thank you. Right? Someone is trying to write Haskell without a PhD. That's a good question. No close, no psych. There you go. It should be the other one, but I like that. Okay, response. While this is an official list of all the headers that should be in most responses, there are a few that are common enough that we should include them, namely content length, the response size of the response body, connection, whether the connection should be kept alive or closed, content type, the MIME type of the response body. So let's build more of the pieces we'll need to send a valid dynamic responses. Remember that HTTP responses follow the same HTTP message format. Start line, field line, registered nurse, message body. The only difference is that the start line is a status line instead of a request line. That's right. There we go. The start line is HTTP version, status code, and reason phrase. For example, this one right here, HTTP 1.1, 200, not found. Bam. Okay, you got that. So you can kind of see how this is coming together here. Some interesting tidbits about the reason phrase from section 4. A client should ignore the reason phrase content because it is not a reliable channel of information. It might be translated for a given locale, overwritten by intermediaries, or discarded when the message is forwarded via other versions of HTTP. A server must send the space that separates the status code from the reason phrase, even when the reason phrase is absent. How do you like them apples? If you don't send that, if you do not send that space, you are in trouble, mister. I love it. I love all these things. Don't you just love that this is server must, right? This is a must send that space, right? You must send the space. Isn't that crazy? TCP report format. No. It's not TCP. It's HTTP. It's the HTTP intermediaries need that space. While the reason phrase are typically included and match one of the status codes, they're not required and should be ignored by clients. Kind of funny. It is kind of funny. And the space, kind of funny. All right, let's create a new package, internal response package, and create a new status code enum. Let's go. Here we go. So we're going to go over here. We're going to jump into here. We're going to jump into here. We're going to have a response. Let's go. We have a response. We're going to have a response. We're going to have a go. Okay, well, what do you do? Okay, good. Okay. We're going to do a little bit of one of those. We're going to have an enum. Is that what we're doing? No, we're doing... I guess we're going to do like OK, status OK equals a status code equals 200. Is that how we're doing this? All right. All right, so I'm not sure if that's what they need, but let's just call it, we'll just call that here, okay? We're just going to call that for what it is. Okay, here we go. So let's see this assignment. We're going to write this response. We're going to have a status code enum. We're going to do those things. We're going to implement a func writer stat. This one. Okay, let's do this. What's the thing? It's HTTP 1.1. Yeah. There we go. We're just going to rip through this because this is just like, now we're just going to have a bunch of these that I just want to get right. You know what I mean? There we go. Now we can go status, bad request, 6 up, that, bam, bam, bam. VI that one, paste it in. There we go. Bad here, bad. Do one of those. Let's go. Paste that one in. Yank paste. There we go. I feel like I'm missing something. All right, what's the problem here? Too many return values. That's right. This does an int and an error. I forgot that it does int error. It does an int error. Gosh. Status line. I forgot that it does that. Status line equals this. I should have known better. Okay, let's go like this. W.write. Yeah. Let's just do that. That seems pretty much right. Do a little one-eyed fighting Kirby. I tried to just kind of vibe code that maybe a little too hard. You know what I mean? Status line equals, right? We can't be doing that. It's a little too much. Right? We don't want to be doing that. There we go. That should be pretty much good. And then we'll go like this. And then we can have a default, which should probably return format error, unrecognized, recognized error code, right? There we go. All right, so we've gotten pretty far. So everything's looking pretty good. We have our status line, we have all those things, and so we should be able to just go like this. What is it? It should be, who cares about that? We'll just hit them with one of those, and we should IO. All right, turn that down. Way too much intensity just then. Way too much intensity. There we go. Implement a function, get default headers, content length int. Wait, what? It should set the following headers that we always want to include in our response. Hold on, what? Hold on, this is a really, this is a really weird one. What am I saying here? Let's see, this function should set the following headers that we want. I don't know this one. I don't think I remember writing this one. That's okay though. That's okay. All right, this is okay. We could do this. Get default headers. Yeah. Okay. Seems a little bit strange, but whatever. I'm not really sure. I don't really understand this one. Why are we doing this right here? Get default headers. That means, okay, that's fine. We'll have this one, and we'll go headers dot new headers. We'll do that one. We'll go set. And then what's the methods we need to do? We want these 4 right here. Okay. Which I think makes sense, right? We're going to do all these ones, right? So we're going to want to do a content length. And we'll do the content length for this one. And then we're going to want connection. And we're just going to set it to closed, right? Because we don't actually need anything beyond that one. And then we're going to go right here. And we'll go content type, which is going to be a text plain, right? So there we go. So we're just kind of setting up these things. I think I know where this is going. Bro, I know where this is going. Why are we copying this out? That makes me feel uncomfortable. All right, we have a little headers, even though I guess it's not that big of a deal. It's really not that big of a deal. All right, content headers, noon headers, do this one. Content length, format, sprint F, do this. %D, go into here, content length. There we go. Because that's how you do it in this area. Okay, apparently it doesn't want us to do headers. Can I just do that? I'm going to do that. Okay, I'm going to do that. I probably wrote this. I just can't remember why I wrote this, but here we are anyways, okay? So I have the status line. That's the first line of the response, because remember, I don't know if you guys remember from just reading it literally 14 seconds ago, we have a status line, then we have field lines, then we have the empty one, then we have the message body. So we wrote something to do the top part right here, status line. Let's go, because remember, on a response, it's the status line. It's not the it's not the request line, it's the status line. The default headers, we want to give it some basic headers. So when we create a response, it starts off with some basic headers, you know, some basic B headers, okay? Now that we have that, we're going to keep on going, so that way we don't mess anything up. And then we have this assignment. We're going to go here. We did this one. Bam. We did this one. Bam. We did this one. Bam. Okay. We did this one. Bam. We got that one done. Implement func write headers. Headers. IO write headers. That does exactly what you'd expect. Ooh, I love that. Don't tell them what to do. Just tell them what to do. You know what I'm talking about? Let's go. Func write headers. Let's go. Oh my goodness. F. Oh my gosh, I couldn't seem to get that one. Let's go. All right, you know what? You know what to do. You know what to do. You know what to do. I'm going to do that as that because I don't like copying things, even though, like, technically, if you think about that, I wonder how this works, because when I copy this, I'm actually not copying the map, right? I'm just copying a pointer to a map, so you could have several copies of an object in which is just actually a copy of just simply a struct that's filled with one pointer, which is like, is it the same thing as just copying a pointer? I have no idea. I don't know how these things work, but here we are. We're just doing a pointer to a pointer, which is a little ridiculous. So maybe I need not to do that. Maybe it would be better just to not do that, but here we are. All right, here we go. So I'm going to go like this. You know what I'm going to do, boys. We're going to go like this. 4. We're going to go like this. W. Lots of W's going on. H. For each. Func. Make that happen. Come in here. Do this. Then W. Write. Equals nil. Bam. If. Var. Error equals nil. Boom. If. Does not equal nil. Then return. Bam. Get that there. Right here. Equals this. And. All right. There we go. Do one of those. And then we're just going to go like that. Format. And we'll do a little sprintf, right? So we're just writing in the headers. This is pretty straightforward stuff, right? Like, I assume you guys can handle its meaning, /r/n. Like, this is easy. Come on. People, this is easy stuff. There's nothing going on here. Okay, there's nothing going on here. We're just writing headers one at a time. You don't know what's going on here? You don't know what's going on here? What does this have to say? Replace this with append. What the hell's append? Wait, now what's the problem? What is append? Append formats according to the format specified, appends the results to a byte slice and return. That's cool. Dude, I literally never knew about. I've never known about append. Here I am, learning about something new. Here I am. I have never even known about that. Very cool. Oh, that's very cool. That's very cool. Crazy. This shows, this just shows Prime is old. Why do you keep saying I'm old? Of course I'm old, dog. New feature, my dumb. It's sort of new feature because it's Go 119, so right after generics. All right, so we did that one. Bam! Okay, update the handle method in your server package to use these new function methods and return our default response. All right, deal. Okay, so this should actually be pretty straightforward. So if we do this one, we're gonna do a little bit of a serve. We're gonna go up here and we're gonna run out this connection. Now, this is where things are gonna get a little bit interesting because as of right now, we don't actually use our server to do anything, which is probably a little bit silly of me. Unused param, well, that's why it starts with an underscore, you dummy. Go, I hate you. Sometimes. I also love Go, but still, it's really like, why you gotta be like this? Yo, Go, why you gotta be like this? Okay, so if we have this, what we want to do is we want our headers, right? So it's gonna be server dot. Is it not server? Wait, where did I put this little, oh, is it response? Oh, crap, yeah, oh, crap, oh, crap. It's response, yes. And right here, I want the default header, so there we go. So I got my default headers, and the content length currently is 0. Right? So content length is one of those interesting ones, which is when you reset the content length. So, okay, so actually this is kind of an interesting thing because, you know, right now when we set something in our headers, right, it just sets it in the headers, right? It just adds it to the thing. But should content length be special? Should content length not get appended values? Very interesting. I don't think I solved this problem last time. Yeah, I don't think this is how I programmed it last time. Well, maybe I did, but I don't think I did. Yeah, see, I didn't do it this way. Yeah, see, I don't like this way. So I was right. Lane, I don't like what you wrote. Because you got to know, you don't know how long things are. Like, the content length should be automatically handled, but you shouldn't be setting things. You know what I mean? We probably need to replace, right? It's almost like our header function also needs, instead of just set, right, it needs something like replace, right, where it's just like, hey, I'm going to replace it if it does equal this way, right? Right? That just replaces the value. Fair critique, yeah. Because yeah, I don't know if I like this. I don't feel like this is good. Like, me personally, I don't feel like this is good. I don't like what I'm writing. But I'm trying to think of, like, how could I write this differently? But we're also just trying to understand how these things work. So maybe it's like, it's okay for this. Maybe there's a better way to go about this. Maybe I'd have a different, what are the expectations of people with headers? It's a good question. It's a good set of questions to understand what the expectation is. Okay, so now that we have that, we have our default headers. And really what we should do is we should actually go and we should read the request in the body. We should read the request. We should handle the request. We should then write out the response. But since we're not doing that yet, let's just do this. We can go like this, response.write status line. And so I'm just going to pass in the con. And what's the next thing? Our status code is going to be our response. Okay, I'm just going to do this, right? And I'm going to go response.write headers, right? Right now we just have it as this. There we go. And that should be a con and headers. There we go. And that's all we're doing. And that should effectively handle this right now, even though that's a default response. I don't really love this, but this will just work close enough. Yeah, we're gonna only use MIME type. By the way, this is really smart in this course. Don't really worry too much about MIME type. This is something you can easily learn and understand. Like, if you were doing a file serve, you'd want to be able to associate, like if you serve a JPEG, you want to be able to associate the correct MIME type, as opposed to if you're serving, say, a JavaScript file. You want to associate the correct MIME type. These are like little, this is when I say the edge cases are literally infinite. These are one of those infinite ones. Now, if I've done this correctly without running any tests, which I'm just going to assume I do because I assume everything I've done is correct because that's how you live a life, I'm just going to simply copy this thing. I'm going to run. I've restarted my server. I'm just simply going to run this. And it's going to run, and it's going to get a status code. It's going to expect this one, and here we go. We're going to run boot.dev, and what do we get? We got status code 200, but we got 0. Oh, wait, what? Oh, crap. Ah, crap. I forgot to do /r/n. Dang it. There you go. Now we see the get. Wait, hold on. Okay, that was my fault. That was my fault. There we go. Now we see it right here. Okay, that was my bad. My bad. My bad. There we go. Whoopsies. That's my fault. I'm the dummy. I am the dummy. There we go. Other comment headers. Okay. We went with content length, connection, and connection type, but there's a few more noteworthy mentions that we won't care about for now. Content encoding and the response content encoding compressed. Is it gzipped? Is it bzipped? Is it broadly? What are we doing here? Encoded does not equal encrypted. Correct. Date, the date and time the message was sent. This is useful for caching and other things. Control cache, other like nice little things. We're not going to do that. Which HTTP header specifies when the response was sent? X time warp. Date. Which, by the way, I need to increase my failed. All right, there we go. We did not get this correctly. Okay, failed +1. I know I got that. I got it. Does anyone else know which lesson this is on boot? Yes, this is the Go. This is HTTP from TCP or TCP to HTTP. I believe it's called like Go HTTP protocol. Something like that. Now that we've got a lot of boilerplate out of the way, let's define our handler function. This will allow the user of our server package to define their own logic for handling requests. Here's a function signature we're going to use. Oh boy, I believe I wrote this one. Now, I definitely wrote this bad boy, okay? Okay, buddy. Okay, buddy. There we go, handler. Okay, okay, buddy, I wrote, okay there, buddy guy, I wrote that guy, okay, buddy? What the hell? Okay, I didn't write a handler error. What the hell is a handler error? Okay, that I didn't write. I don't know what the heck that is. Remember, the official Go one uses this one. Yep, that's right. We have a response writer and an HTTP queue thing right here, and an HTTP request. What's a handler error? Brother, what's a handler error? Okay, maybe I did. Okay, I'm gonna say I didn't write this, actually. I'm just gonna say I didn't write this. Okay, I didn't write this. I didn't write this. Type handler error. My guess is this is just an error. It's a pointer, though, so that, like, I'm confused a little bit by what that is supposed to mean. Hand L error. Okay, it doesn't really matter. Let's see what it does, because I don't know. I'm looking ahead too far without trying to understand it. The main difference between our and the official one is we'll use more general IO writer instead of the response writer. Correct. We'll use our own request type that we just built. We'll return a handler error. It's just a structured error type that makes it easy to always return a proper status code and error message. Okay, truing. So I'm going to go like this. Struct, and then I don't really know what to do. I don't know what to put in here, so I'm just going to put error. I honestly don't know what to put in there, right? I don't really, I bet you I put this in here because I was smart, but I'm forgetting why I put it in there. Okay. Step 1, create a handler function type and handle error struct type in your server package. My handler or handler error contains a status code and a message. Interesting. Status code, message, string. Okay. Porque? Update server to accept a handler function as an argument. Truing. Okay, we can do that. I'm trying to remember why I did this. Hold on. Let's take this, and let's take that out, right? Let's take that out, and let's go into here, and let's go to server. All right, I'm going to paste that in here. Status code. Ooh. Where did I define my status code anyways? Status code and request or response. That seems wrong also. That doesn't seem right at all. So I'm going to take that out. I think I put that somewhere wrong. Where did I put that? Maybe it could be in response. Yeah, I could see why I could make the argument for why it needs to be there. I feel like I would want to think about that a little bit more. Maybe I'd want to put that in some sort of generalized handler so it's a little bit more understandable. So there we go. So we have this bad boy. So let's go like this. We have a server, and we do a little bit of a port, and we go like this. And then we also have our handler, right? The best part is this is like a complete mystery to me right now. I actually have no idea where we're going, right? Like, that's the fun part. I actually don't even know where we're going. Where are we going? I don't even know. All right, so we're going to do this bad boy. Right? This is kind of fun. It's like a mystery. I'm like having a mystery going on right now. All right, so I do like this. Create a handler that I like that. I know I have this in here for a reason, and I know I put this. This is not a lane fault. This is me. The problem is I'm trying to solve this course ahead of time, and I'm like confused why I did that. So we'll see what happens. Okay, create some logic that writes the handler error to an IO writer. This will make it easy for us to keep our error handling consistent and dry. That does not sound like a phrase I'd say. I'm going to say, but I'll pretend like I wrote it. Shh. I'll pretend like I wrote it. All right, so we're going to have a server. We're going to have this. Let's use our server connection, right? So we're going to have this one. We're going to get the default headers. Then we're going to go like this. Error equals s.handler. And then we need to write something here. And so we need our own little, our own little IO writer right here. That we need our own IO writer. And then we need our own request writer, right? Because we're going to have something, right? There's a way to do a buffer, right? Buff equals, is it Buffio? Is it Buffio? Is Buffio the one we want to use? New, how do we want to do this? Because I want a writer, right? I want my writer. And there's a way to do a buffer. I thought there was something called buffer. I thought there's a buffer module that was just like literally called buffer. Am I wrong on that? Is it bytes? New buffer, right? There we go. And so I can go like this, right? I can just hit him with one of those, right? And this buffer implements creates and initialize a new buffer using the buff as an initial contents. Takes ownership, and the caller should not use buff after this call. Yes, the buffer is intended to prepare a buffer to read existing data. It can also be used to initial size. Used to set an initial size of the internal buffer for writing. Okay, so we could do that. Buff should have the desired capacity, but a length of 0. In most cases, buffer, okay. So I should be able to just, I think then I can just go like this, writer.write, right? I think I can just write to it, and I think that's fine, right? So I should be able to go like that. If I've done this correctly, I should be able to do this. So I just get I pass in the buffer, which is now a writer, and I go like that, and then I also need to pass in what? I also need to pass in the request. So then I also go like this, request error equals, what is it? It's going to be a request dot, let's see, request from reader. We're going to pass in the con. So there we go. This is the whole course now comes down to this line, right? Which is we're going to get default headers. We're going to create the writer. We're going to do these things. If we have an error, what do we need to do here? Well, I need to go, right? I need to take these bad boys, do one of these ones, and I need to write response line status, bad request. I'm just going to hit them with the bad request, right? If you give me an error, it's a bad request. I don't want to do anything. That's all we're doing, all right? Right? All right, so if we don't do this here, then now I'll go down here, and just to make this easier, I'll do this little writer. Error handler, right? Handler error equals this one, and then this one requires a request, so we have the nice little request right here. So there we go, so we have the handle request. So that means if whatever you've written, I now need to start doing some basic replacing on, right? So I need to go like this. If handle error does not equal nil, wrong language, does not equal nil. Now we need to do something with this, which I still to do. Why did I do this? And what should I do? To me, in my head, if there is a handler error, I'm just going to go like this. I'm going to yank these two, paste these two, and I'm going to go status internal server error, write out those headers, and we'll call it a day. Now, I noticed also something. My handler, I should theoretically be passing in also the headers to write to, right? In my head, I'd also need the headers because in case you need to write different headers. Does that make sense? Yeah, so there we go. So we have the handler error, we have the handler, we have all these things. We can write out these things. Else, I'm going to do an OK status. We could also have like a hey set status. That's why they have like, if you go here, this is why there is something like in the official Go one, right? If we go back one, where's the official Go one? Where the heck did the official Go one go? Did I lose it? Was it not right here? Oh, yeah, it has a response writer. That's why. The response writer allows you to do things like, I believe, set status. So you can set your own status. A bytes buffer, a UFC announcer. Yeah, will you update the course? What do you mean update the course? It depends on if I like what I've done. I think I could have, I think right here, instead of having this handler error, I think it might be smarter not to have that handler error and do something different. I'm not really sure why I did that, why I wanted it to be so specific. It kind of feels like if your handler returns an error, then you have an internal status error. If you try to parse the request and you have one of these, then it's an error. But I guess you could also say, you could technically also say that you have a request that's actually successful, but then that request is actually bad. But then you'd probably want to handle this differently. I see why I did this, but I don't think I really love the way I did this, right? So I could do a status code right here, right? So I could technically, like, say I expected an authentication token and you didn't, or an API token, you didn't give me one, I'm going to give you, I could send you back technically like a bad request, right? And so I think that was the point of that. Server also serves server, but it doesn't do anything. Yes, it does. Okay, look at it go. We did it right here. We're doing S handler. So we're still using the server right there. We're going to run the connection, do all this. We're going to write headers, all this thing. And then we need to go like this. Length equals, what did I call this thing? Where did I do my writer? Okay, writer, that's right. Writer dot, can I do bytes? There we go, cool. So I can grab the bytes, which means I need to go like this. I need to go headers. Did I call it headers? Yes, nice. Replace, and I need to go content length with length, format dot sprintf %d length. There we go. We're going to set this one. So we're going to set that one. We're going to replace this guy right here. We have these ones, which means I should also take this. I should write the status line. I should write the headers. And then really, I should take the connection and write the body. Data. Body. Length. Body. There we go. Body. Right? There we go. Yeah, see, there we go. So that's the last part. We get the body. I reset the content length. I write the status line, I write the headers, and then I write the body, and we call it a day. Let's go. Does that make sense? All right, so here we go. So we update the handler method, parse the request from the connection. We just did that. We create a new empty bytes buffer. We effectively do that. Nice. We call the handler function. If it errors, write the error to the connection. Nice. If the handle succeeds, create a new default response header, write the status line, write the headers, write the response. Oh, nice. We did this all. In the main function, let's create a handler. Yep. Okay, let's do that right now. All right, here we go. So let's go into here. See, this thing is all wrong. Let's go func. All right, there we go. You know, there we go. So we have these things. So let's go, whoopsies. Let's go 2, 2, there we go. Return nil. All right. Let's go like this. If a request target is your problem, return a 400. All right, let's go like this. Ooh, I wonder, how does message go? How does message go? Your problem is this one. Is that a body? Or is that supposed to be the reason? Okay, so one, I'd say this one. Okay, here, I'm gonna actually report this one. Have you found about it? Yeah, yes. With the message, is that supposed to be on the reason or the body? I would assume reason. Maybe? All right, like, I don't even know. Like, where exactly do you want the things, right? Yeah, okay, so it is. Okay, so it is. Okay, yes, you can actually tell right here. Okay, my bad. I should have read forward. I should have read forward. It says it right there. My bad. All right, there we go. Okay, we're going back loud again. For a second. Here we go. If request line dot request target equals your problem, then wrong language. Else if, we'll just yank that bad boy, paste that in. Else we'll do this. Okay, there we go. And then we're going to go into here, and we're going to say my problem. There we go. False reporting due to skill issues would be failed to increment. False. Okay, there we go. And so we need this one right here, my bad. Okay, so that means when I do all of this, I actually need to go to the server, and when I have these little problems right here, when I have an error, I'm going to write the status code, and then I need to write the headers, and then I need to go con write body, right? And the body is going to be byte handler error message. Right, this is going to be crazy. Do we get this one? First try? I feel like I could potentially get this one. Server response internal server error. There we go. And then we should probably have message. I don't really like how my I don't really like how I have response that hands. Like, I think I'd do a little bit more of a holistic package if I was doing this differently. You know what I mean? All right, there we go. So this one I want as status, bad request. And then I'd want this one as your problem, not my problem. Yep. All right, boom, boom. Otherwise, all good for real, on God. All right, we're going to go like this. W dot right. There we go. Oh, yeah. We're going to do that one. Okay, so I think I did this one. I think I did everything. Obviously, look at that. I don't like how I wrote it, but I think I'm happy with what I've done. All right, so remember, okay. All right, here we go. Now, if this doesn't boot up, that's fine. That doesn't count as a first try loss yet. That's okay. See, that's okay. Easy. Easy. It's just because I am too lazy to go and check everything. All right, what's your, let's see, what do you want to do here? Response 36. Wait, what? Wait. Hold on, rerun that one? Okay, I was about to say, what? I just forgot this. Serve. There we go. All right. We've always had, we have the same rule before a bunch of people call foul, which is if it doesn't build, it doesn't count. That typically is how it's always been. If it doesn't build, it doesn't count because it's not a logic error. It's just that you always get to at least build it. Okay, so run that. Ha! Ha! No! Dang it. Okay, here's what we're going to do. We're going to go like this. Here's what we're going to do, okay, people? Okay, I'm going to declare... I declare my body, people. All right. I'm going to do these bad boys, okay? We're going to do these guys. We're going to have this one if there's an error. If there is an error, we're going to go like this. We're going to go like this. Var status equals status code, right? And I'm going to go like this. This is going to be a response. Okay, I will take the blame on that one. All right. If I have a handler error, I'll go like this. Status equals handler error response code status. There we go. And then I'll go body equals, can I just go like this? Can I go bytes.new buffer, and I can go byte and pass in handle status handler error message. There we go. Right? Did I not do this correctly? What's wrong with you? Oh. Can I just set the writer to that? I think I can just set the writer to that. I guess I wouldn't want to set the writer to that, right? I'd want to just go like this. Yeah, I'd want to set the body to that. I'm just being stupid. I'm just like, bros, I'm just like being stupid right now, okay? I just really want to. Then we're going to take that one. There we go. We have these ones. And then we're going to replace this one with the length of the body. And then we're going to do a status line. And we're going to go like this, a status. And then we're going to go in the headers. And then we're going to write the body. Okay, there we go. That should be the answer to that one, which should now do that one. I forgot to set the content length. Oh! I hate that. Anyways, stupid. Whatever. Stupid. Who wrote this shit? Code review. I just want to point out a few of the ways that I implemented some of this and talk through the decisions. First, a server and listen, right? Oh, bam, 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 bam. Did I write it the same way? Oh, I kind of wrote it very similar. I guess I did it a little bit different here, right? Yeah, see, I did this a bit different. That's fine. You'll notice they're very similar to our original TCP listener with the added handler. Yeah, they're very, very similar. I think this is one way you could do it. I've just been like trying to adopt more of a Elixir style, and so I'm just like passing this in as the first argument instead of hanging it off the object, expecting some sort of more like OOP style or just kind of class-based style. Instead, I just have like data and then pass in the stuff. So it's like a blah, 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 blah. Should content length be treated differently? No, you should be, okay, shut up. I should have read, okay? You'll notice that that they're very similar to our original TCP listener with the added handler that to actually handle and respond to the HTTP request. In fact, the interesting part is in the handle method, right? The handler method. We're going to do this. We're going to read all this good stuff. If there's an error, we're going to have a handler error. I should have probably put this into here, probably put a bad request. I didn't do that. Instead, I did this whole thing. There we go. We have a nice little handler error. We have this one. If we have this one, we can just write, oh, nice. That's cool. That's cool. I did it this way. That's actually a one way to do that. Else we do it this way. I like the way I wrote it this time. I think this is not great code. I think that, again, I think I at least wrote it a bit better this way, kind of collapsing them into the same thing. I think that that's a little bit nicer. Either way, it's pretty straightforward procedural code. Procedural code is beautiful. You know, anyone that always dogs on procedural code, I think they're just dogs, right? Procedural code is great. Something interesting things to note. I used raw netcon to implement both the IO reader and writer interfaces, so it works perfectly with our this one and our response writex functions. Our user supplied handler functions are kind of wonky. In the event of an error, they return a handler error and don't write to the IO writer themselves. But in the event of success, they do write to the IO writer and return them and don't return error. Yeah, it's just like a little bit. It's true. It's weird. I agree with you. Right, okay, refactor. I'm not happy with our current implementation. It constrains the user of our library, our main package for now. But hey, the startup is going to get monetized, is going to monetize it eventually. In a few ways, errors are always handled as plain text responses. Headers are always the same. Let's fix that. We're going to need more flexible function signature. That's right. Right? So we have this one right here, right? I'm thinking something more like this. Writer. All right, hold on. What is going on here? We're going to have a response writer. Nice. Okay, nice. So we're going to do our own writer here. That's right. This does make it a lot nicer because you'll notice that this actually looks just like now the Go standard library. it makes perfect sense having your own writer, because if we create a new writer struct, this will allow us to modify the headers, status code, and body of the message as they see fit. This will give them control to respond to the HTTP request in any way they want while still encapsulating some of the boilerplate logic. See, this is much better. Can we all agree this is much, much better interface? This is why probably the Go team landed on this exact thing, because this makes a lot of sense, right? You can see why they've mandated it. That's why the handler error. Yeah. Now I can sleep well. Yes. I know. I forgot why I did that, but now I remember why I did that, which was actually to throw it away. That's why I was having such a hard time there, is that my own self knowing the correct answer was doing something incorrect to go, no, actually, this is why it makes more sense, is because or else you just do this weird dance where I could have written stuff that gets ignored, and then you pass like these two different things, prime padding, old prime on the back. Dude, I am like Obama meddling myself so hard right now. Yeah, I know exactly what you're saying. Yeah, now it makes so much sense, because now I'm looking into the, now I'm looking not in the past anymore. All right, the assignment. The goal here is to change our handler in the main package to respond with HTML instead of plain text. We'll need to do this one. We'll ensure that the raw or the handler function can write raw bytes to the response body even in the event of an error. Give the handler function control over the response headers, content type, all this stuff. All right, so let's update our response package by exporting the following and go implement the innards. Type writer struct. Yeah. So let's go over to response. There we go. Let's go like this. Type a writer struct. All right, let's go like this. And the writer, what do we do here? We're going to want the following functions. All right, let's yank these definitions really quickly. Let's go like that. Let's go like this. Let's bring them down here. Paste those in. There we go. See, I should have put these all in the same. See, for whatever reason, I put these all as separate. For whatever reason, while doing this, I put these all as separate packages. Headers, request, and response really should have been one package. I don't know why I didn't do that. Anyways, this is just what I did for whatever reason. Headers, right? All right, so there we go. That's what we need to implement, which shouldn't be too hard. So I can just go in here, write status line, go into here, write the status code. The status code equals one of these things. We kind of have this nice little status code that we're kind of writing right through right here. That makes a lot of sense. We're going to have IO. We're going to have a writer, right? We're going to have the writer that has an IO.writer, I think. That probably is right. Yes, let's just call that thing right for right now. And we're going to have io.writer.write. There we go. Yeah. Let's go. Writer.this thing. That's the underlying writer. That's the con. That's the connection, right? So I can set up all these things. So we have that nice little thing right there. Let's delete that one. Let's go in here. Let's take that one out. That should be easy little transition right here. 7 down, do one of these, and then just hit them with the writer.write. So it's everything's pretty much the same. Write body, exact same thing. Writer.write, write the whole body. The body is going to be P, this thing. And even though we should probably be checking for errors, let's we can check for errors. N.er equals this. There we go. We can return N and er. And by also having N, I can go like this. I can go write these headers. So I kind of need access to these headers, right? Write headers is a little bit interesting. Let me understand why we did this. To update our response package, export the following and implement the innards. I also feel like I don't like... now that I'm looking at this, I kind of feel like this is a bit wonky in the sense that we should not have... write headers and write status line and write body are kind of like... I guess... they should be private methods. Really, we should have these as private methods because the person who's implementing these things shouldn't have them. They should be able to have status, right? You should be able to have a status, and you should be able to just set the status. Okay, this part is optional, though I think it is a nice touch. Add a writer state to my field writer struct that ensures that my user of the library calls write status, write header, and write body in the correct order. It just gives them a nice explicit error if they do stuff out of order. Yes, we could do that. I think that is fine. Update the handler in your HTTP server's main body to use the new package and use HTML instead of plain text. Here's an HTML to use. Okay, there we go. Nice. You might want to expose a new method from your headers packages so that you can override the default headers for a key instead of adding them. It's on. Yep. Override the default keys instead of adding them. I already did that with replace because you wouldn't want to have to like write all these out. But I guess this is the raw components. Actually, you know what? I'm actually not upset about this, right? Because you'd want your server to have access to all these underlying things right here, such as write status line, write headers, write body. Because this is supposed to be like the low level package. Then you construct your server on top of it to be able to do request routing and all that stuff. And then your client wouldn't be using these primitive pieces. It'd be using like the larger set of pieces. That's probably where I'd go with this, right? That's probably where I would go with this, if that makes sense. Yeah, that makes sense. I can see why I did it this way as a means to like build up the primitive pieces to be able to build the next part, which is that I always wanted to do a course on like building an actual HTTP server. Meaning like, okay, so how would you build something like Echo, right? Or how would you build something like Jin or all those other things? Which means that you need these underlying pieces, and then you have to take these underlying pieces and build the next step, which is going to be like string parsing of the different paths, being able to route to different handlers, all that kind of stuff, which is what we don't have. Okay, so I think that's all right. Yeah. Okay, I'm going to keep this. I think how I've organized the code on this, not the best, but this is like part of the fun of just implementing stuff is that when you're just implementing for fun, you kind of toss everything around and you just remember why you want to put things. This is why it's impossible. People always talk about how they think with their, they sit down and you should be thinking more than you're writing code. I just have never understood that because I need to write code and then I can go, okay, I see why I wouldn't want to do it this way or that way. I'm more of a learner by writing than I am a learner by just sitting down with pen and piece of paper. I just can't do that. You know what I mean? Okay, so that means our server needs to change its handler a little bit because the handler is going to be right here. So instead of an IO writer, let's have a response. Writer right here. There we go. So we're going to pass in this response writer, which is currently a struct, which is... we should never be passing in this, but here we go. We have the response writer. Let's go. I think this will work for me, for now. I'm actually fine with this because, like I said, I think this would allow you to write a better server. I'd have to still think about that because I haven't quite done it, but we've done that. Booted, boom, boom, boom. All right, so let's also do this one. Let's see. Update our handler to in your HTTP server package to do this one. Okay, that's kind of funny. Okay, I guess, we can just do this. It doesn't really bother me to do this. All right, so we're going to go like that, and we're going to take this guy, and we're going to take this guy, and we're going to do that, and then we're going to go back here, and then we're going to go here, and then we're going to go here, and we're going to drop that. There we go. We're going to have this one. We're going to have our set. We're going to have this one. We're going to have a server, and then we need to have our, let's see, what do we have right now? We have a response right now that we effectively have, and so we do it this way right now, which we don't want to do it this way. We actually want our response writer, right, is going to be a response writer. And then our writer underneath will be our connection, right? Func new writer. Writer is going to be an IO writer. There we go. Oh my gosh. Writer. Let's just do it as a writer. I don't really know how else to do this. Writer. There we go. And then we'll do that. And then we'll do this. There we go. That seems better. A new writer. There we go. And we'll pass in the con. There we go. So we have a response writer. And so I'll go writer. And there we go. So we can write in those things if we want to. We can write in, say, our status line. We don't need a connection anymore, right? Because we already have these things right here. We can write the headers, which is going to be this, which is going to be this. One is that. Okay, we're going to have to do that. That's fine. That's fine. All right, so we're going to have a new handler right here, which is actually going to take the response writer. Whoopsies. We're going to take the response writer. And then we won't have one of those. There we go. So we have these two right here. So we have our underlying writer, which we don't need to worry about. I want to actually pass in. Yeah, okay. Let's go like this. We don't need that thing. We're going to go like this. We're going to go. See, the reason why I don't necessarily like this. Let's think about this for a second. Let's just think about this for a second, is that I don't know how much content to write, right? And so let's go back to our writer. Let's go back to our writer because it's still not how I like this, right? Because when we write the body, I don't have access to the header, so I can't update the headers, which means that, yeah, it's just, I'm having a bit of a hard time because I'm envisioning this as a client library, which it should be a server. It's like a server atomic pieces library. So I'm just having this weird thing where I'm just like, meh, and I'm not really liking it. So I can really get rid of all of this, right? And there we go. Right, so this all goes away because everything else should be just done for. So if we can't even write our own connection, we do the whole bad request business. Else we do all this right here, which we're going to take this, we're going to write all of that stuff out, and then we're going to go back to this thing, and now we need to kind of consider this thing right here, right? And so I'm going to go here, I'm going to erase this one, or I have that one. All right, okay. All right, let's do each one of these ones. There we go. So we're going to jump into here. I'm going to take away these headers because I don't think we need these headers. We don't need these headers because we're putting it all on the responsibility of the person writing or implementing the library to like pass in the headers, how they want to do all that. This would actually be inside of a server. So then I'd go headers equals headers dot new headers. There we go. Or where did I do the default headers at? Response default headers. Those are really nice. I should probably just do response. I should probably do the response default headers because they're nice. There we go. We're gonna take that bad boy. We'll get this nice bad one right there. We're gonna jump in here and we have these three ones we want to implement. Sorry, I'm thinking out loud as I like work through this. I always have to think out loud how I want to do things. If we have a your problem, right? I can do something that looks like this. I can do w dot write status line response bad request. I can do w dot write headers. Now this is kind of the interesting part, which is how am I going to do this? How do I want to do this? Right? How do I want to do this? Your response kind of sucked. Here's what I'm going to do. I'm going to go like this. Let's go like this. Func, let's see if 400 response, right? I guess we can go like this. Respond 400, right? And I'm just going to do a byte response back, return, and let's just go byte. Right, I don't want to put that in the code. Right now we just have these kind of hard-coded, right? We have these all hard-coded. These would be what the client, like, this is kind of like what the client would technically do. It would just, like, write really simply. But I'm not even considering that right now. All right, here we go. Func, respond, 200. There we go. So we're going to have those ones, so I can go like this. I can go body equals, I'll just go like this, respond 400 for this one. You know, this isn't the coolest way to do things. We're going to have those headers. We're going to have headers replace content length with the length of the body. There we go. And then we have to do format. You know what? I'm tired of that. You know what? I kind of feel like I want something that's like an int. You know what I mean? Maybe I should have added a better one to do a little int there. Sprint F. That'd be kind of nice, huh? Because it kind of feels like I've done this a few times. All right, there we go. So we're going to replace with the content length right here. There we go. Awesome. And so with this one, actually, I can do just like a little fun little... Could we do something with this? I bet you we could make this a lot nicer, but we're not going to make this a lot nicer. Okay, there we go. So we're going to do headers. We can do headers. We can write the status line. We can write that one. Then we can write the body, which is going to be the body. See, there we go. So these are all this one, right? The headers. What is the headers? Is that thing? Okay, perfect. So that means I go like this. Body equals respond 200. We'll do one of those. Who cares if we have to make a little bit extra? You know what I'm talking about. Status equals, what do we call this? Response. Response.status. Okay, there we go. I'll just make the default idea that that's what we're doing. There we go. We're going to do that one. And then we're going to go like this. Status equals... There we go. Do one of those ones. Take these guys. Yank those two. Hit one of those ones. 500 status internal server error. Else we don't have one of those. Take one of those. All right. There we go. There we go. And then go w.write status line equals status. All right. So that's kind of like how you'd... I mean... This is a very crappy way to implement a server, but this would be like the basics of getting up a server. Because then you could do routing right to subhandlers. Because you could imagine that if you had some sort of set of subhandlers, you could do some sort of subhandler, right? That can do some sort of writing to its own body. And then you could take its own body, right? You do that, right? So, you know, somewhere in here, right? You do something in here, right? Blah, blah, blah. You could have this, like, you know, subhandlers. You'd have to, like, find based on request dot, what is it, rec dot request line dot target, right? You could do some sort of find on the request line target right here, get that handler out, and then you could do some sort of writer, which is going to be some sort of, you know, like bytes dot new buffer, right? You're going to do one of those, and then you could do like a handler, and you could like call into the handler with the writer, the headers, and the request, right? And then now this thing does its own writing, and it can actually do any sort of, and then you could do an overriding of the writer to be able to set like various status things and do all that. And then boom, you could really have your own server. Anyways, there you go. Sorry. I just kind of want to think about that in like the longer one. There's a lot of subhandlers. Now I'm saying, well, I mean, there is a lot of subhandlers whenever you're doing server stuff, because you're also going to want to take this thing and you have to do one of those, I forget what they call them. It's like a recover, right? I've never actually used recover in Golang, but you'd have to recover from if your server panics, you'd want your handlers to be caught in a recovery. And then by catching this thing in the recovery, you'd be able to make sure that your server doesn't go down based on a panic, but instead reports the panic out, does all that stuff. Anyways, so that's kind of like what the end goal of this is, to show you, like, you could see how Echo was created now, right? You can see how Echo could have been created. Instead of just like having a hard-coded one of these, you'd have to go find the response. Like, now you can see it, and you're like, huh, okay, huh. All right, so I have no idea if this is gonna run. Let's do one of these things. Let's do one of these things. Yep, I forgot I just put in a bunch of fake one of those ones to kind of give you guys all these little nice things. Okay, oopsies, no, whoa. This thing is what I want, okay. Which is that one in? That's in server. Do one of those, there we go. No, stop running that thing. It's not even the right one. There we go, here we go. All right, copy this one. There we go. Can I do this? Damn, okay. Oh, no, I forgot about that content type to X to A. Dude, I did it again. I forgot the content type. I forgot the content type again. You know how many times I've done this with the content type? h.replace.content type equals a text. Dude, I've done this how many times? I gotta quit. Dude, I have to quit doing that. All right. I never said I was good at reading, okay? This guy works at Netflix. False. I used to work at Netflix, jackass. Got him. You think I'm employed? Have you seen this coding? All right, here we go. So let's move on. Let's pretend you have a server that receives a request, and that request wants to download a file. But the file you need to download is 10 gigabytes big. That's a big file. You can't just simply load that all into memory, be able to calculate out the checksums, and be able to send it out easily, because remember, we need something like content length. You need to know exactly how many bytes are coming down. And what if you don't even know how long this file is? What happens if you're receiving it from another server or a different protocol that doesn't even specify the length? You need a way to be able to send down data in such a way that you don't have to specify the length up front. This is called chunked encoding. And chunked encoding is actually a relatively trivial form of encoding where each HTTP body contains how many bytes are in the body and then the data bytes. And now it's your job to reassemble each one of those chunks. Another kind of neat thing about chunked encoding is at the end, you can provide what is called trailers. Trailers allow you to add extra header fields at the end. You have to specify what header fields you would like to add at the end to begin with, so that way you can't have just infinite trailers at the end. But let's say that you want 5 different trailer fields. You could have them all appear at the end, and they'd all be a part of the headers. If you've ever wondered why headers are asynchronous, well, this is why. To run through the basics of the chunked encoding algorithm, it's pretty simple. You're gonna have your status line, you're gonna have your headers, and then you're gonna have a body in which is gonna have a hexadecimal number that is gonna be the amount of bytes that this message contains. So you're gonna have another registered nurse right here, then you're gonna have your data, and you're gonna receive multiple of these style of messages where you're gonna keep on sending more and more of the data down, and eventually, at some point, you're gonna receive a message that is gonna have a 0 for the length, which is gonna contain an empty data field. This is the last and closing chunk of a chunked encoding. That way you don't need to know how much data you have. You simply need to just be able to keep on receiving data and storing the data in an appropriate manner. All right, chunked encoding. We're to the final part of this whole thing, which is gonna be chunked encoding, which is gonna be just a couple pieces. There we go. This should be pretty straightforward, okay? Should be pretty easy. So up to this point, we've assumed that HTTP messages are parsed and sent byte by byte, but we've still treated the message body as a single block of data. This works great for many use cases, but what happens if we want to send updates bit by bit? Well, remember our fundamental unit of HTTP, the HTTP message right here, start line, field lines, and message body. Turns out message body can be a bit deceiving. It's rather flexible field that contains variable length of data, known only as it's sent by making the use of transfer encoding rather than content length. So here's how you do it. Transfer encoding chunked. You could do this bad boy, length of data, length of data, length of data, length of data. There we go. where n is just a hexadecimal number that's indicating the size of the chunk in bytes. By the way, do you like that it's a hexadecimal number? Hell yeah, brother. Hell yeah, dude, saving so much room, dude. I mean, seriously, we're saving room, boys, okay? Because you know what? If we would have used decimal, it would have been, like, huge. So we better use hexadecimal. Right, dude? Like, you're using hexadecimal, reading it 1 byte at a time. Like, are you really getting anywhere with this? You're not getting anywhere with this. You know what I mean? All right, anyways. All right. I always just thought that was funny when I read this. I was just like, hexadecimal? Who the hell does that? And it's just a hexadecimal number indicating the size of the chunked in bytes, and the data, this is the actual data. So you'll notice that first we say like 0xFF, and then we do the length of data, 0xFFF, and then we do the length of data, 012. You're just like, okay, cool. So it'd be something like this. Oh, you don't even do the 0x. That's right. You don't even do the 0x. You just do this. Never go full Java. Chunked encoding is most often used for streaming large amounts of data, real-time updates, and sending data of unknown sizes. We need our server to support chunked responses because occasionally our servers acts as proxy for another server. Any request to HTTP bin endpoint will be proxied to an amazing httpbin.org service, a wonderful online tool for testing HTTP stuff. For example, get localhost, this right here, will trigger a handler on our server to send a request to HTTP bin org stream 100, and then and forwards that response back to this. Oh, is this true? Okay, so this part, Lane went way different on this part. So this was not something I wrote. So hey, guess what, everybody? We'll be doing this one together. All right, cool. Very exciting. HTTP bin org stream 100 streams 100 JSON responses back to our server, making it a great way for us to test our chunked response implementation. Okay. Add 2 new methods to your response package that do what you would expect based on the knowledge of your chunked encoding. Write chunked body done. Interesting. Okay, I think I see what's going on here. Chunked sizes should be in size in bytes of the data and should be hexadecimal format. Add a new proxy handler to your server that maps hbin x to x, supporting both proxy and chunked responses. I use string has prefix and trim prefix to handle the routing and route parsing. Be sure to remove content length header from the response and add transfer encoding chunked. I use HTTP GET to make a request. Okay, interesting. And then I use buffer size, this one to, and then print in on every call read. Okay, interesting. I recommend using Netcat to test your chunked responses. Curl will abstract away the chunking for you, so you won't see your hex and CRLFs characters in your terminal. So there we go. We can echo this one right here, and then we can do a nice little one of these ones. Okay, very interesting. Oh yeah, also, Lane literally ran into a bug while using curl. Curl turns out had a bug and screwed him for a little while. And I think he was blaming me for a little bit at one point. He was like, dude, I don't love you anymore. And I was like, dude, I love you though. What the heck are you doing? I actually also dropped my buffer size when debugging so that I could have more deterministic 32-byte chunks, and then raised it once everything was working properly. All right, interesting. Let's find out what's happening here. So this is a whole new way. So this is not the way that I did it. See, I was doing it the other way, which is that you actually make a chunked request. But okay, here we go. Let's do this. Let's do chunked encoding. Let's go the other direction. I'm ready. Okay, so here we go. So we're going to have to do this one. So if we're going to do this, we're going to have to change things up. So we're going to use transfer encoding. So that means we're going to need to go to our headers. Here, hold on. Checkpoint. All right, headers. All right. So that means we also need to be able to go like this. Delete. Oh, whoopsies. I didn't mean to do that. There we go. And then go delete. There we go. What's your problem here? Found H. Wait, hold on. Wait, what? Wait, hold on. What? Is it supposed to be like that? Is delete more like that? There we go. Strings, is that a function? There we go. That's how delete works, right? It does the collection and then the key. Okay, yeah, there we go. So we need a delete. All right. Name of the string. Yeah. Do the truffle shuffle. We're trying to. .pixel. Thank you very much for that tier 1. I appreciate that. Relationship ended with Prime until I've updated to curl. Until I updated to curl 812. Yeah, it's true. Lane was not happy. All right, so there we go. So we got that one. So let's look at the next part. So this should be pretty easy. We're literally just doing hexadecimal numbers, and then we're just doing this one at a time. Now, one thing I can't remember with Go, which is how to actually get hexadecimal numbers back out, If I'm not mistaken, I bet you there's some way to actually convert one to another inside of the standard library. And I've never used HTTP bin, right? I've never done this one right here. So let's go like this. So let's go back to our little, this guy right here. And we're going to go like this. Else if a request line. Let's go like this. Strings has prefix. Where are we going to do? Rec line has prefix. And then let's go like this. Let's go has prefix that, right? So if it starts off with this, that means we need that. We actually need that. Yeah, we need that to make sure we're doing the right thing, because then we also need like the whole like XXX part that'd be like, hey, this is how many of these things to do. And so let's do something a little bit different here. How are we going to handle this one? For the sake of this one doing chunked encoding, we need to be able to take all these responses and get all these responses back. I actually don't even know how this thing works. So what is curl here? What is curl verbose HTTP what the heck is this thing? I've never even seen this thing before. That is stream 100. Let's go stream 5. All right. So we do a little bit of this, blah, 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 do a little certificate. Okay, we're using HTTP 2, so that kind of is annoying, but whatever. Get stream 5, we're going to be able to do this one, so we don't even get to see the chunked encoding. Okay, we're using HTTP 2. There's a way to disable HTTP 2, right? What's the way to be able to disable HTTP 2? How do you disable HTTP 2 in curl? That's right. I remember that. I knew there was something to do here. Because I just wanted to see what it does. Do you actually get to see all that stuff? All right, so we do all this one. Connected to HTTP bin, content length, access control, allow credentials, and then we do this nice little HTTP bin business. I was hoping to see the body. I was hoping to see what it sends back. Okay, so it's hiding some of the details in here. Can you do something like, is there like a triple super one? Okay, that's too much. We have too much data. Too much data going on here. Okay. Too much data. Way too much data. So how are we setting this thing back? We're doing a little get. Okay, so it does transfer encoding to us. It does chunked transfer encoding to us. We are going to, and then hold on, how are we responding back? Hold on, I'm actually confused as to how this course, what this course requirement's going to be. Okay, let me just reread it. We need our server to support chunked responses because occasionally our server acts as a proxy for another server. But are we even really supporting chunked responses? Honestly, Lane, I think I might have to help you rewrite this part because I'm actually genuinely confused as to what to do. So, because we're not parsing it. We're not doing a request here. I think originally I did this as a request, right? I'm going to make an HTTP request. Read it from, okay, I see what you want me to do here. Okay. I see how you've done this. So you're going to want this thing, right? And I'm just going to go like this. Are you guys ready for this one? So I'm going to go like this. I'm going to go, what is it? Right, dude, how do you do HTTP again? This module has always been a little bit confusing. Let's go like this. This is not, for me, this is not Go's proudest moment, is this. All right. I'm just saying. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I'll go like this. Plus, let's yank that thing and go like this. Target equals this just to make it easier to write and read. Target, let's go length of HTTP bin, right? There we go. Right, there we go. We're going to take the length of that. There we go, because that should be the stream business that we do all that thing from. All right, fantastic. We're going to do a get. The get is going to return a response and an error. We're going to have a response and error equals this. If we have an error, if error does not equal nil, then let's go like this. We're going to take this bad boy and we're going to respond with a 500. Yeah. Right? There we go. We're just going to respond with a 500. Okay, fantastic. It was a 500. I don't know what happened. Else, what I need to do is I need to respond differently. Okay, yeah, I think I could do this. I think I could do this. I think I can do this. Dude, this is gonna be some spaghetti code. Brothers, I'm about to write some spaghetti ass code, okay? Ass code. You may have heard of it. You ready for some spaghetti ass code? Anyways, okay. We're gonna write some spaghetti ass code. Here we go. Yeah. Mamma mia. That's right. We are about the mamma mia right now, okay? So I'm going to do a status line. I'm going to go like this. Response. I know. This is just let it happen. You know what? Just to make... Yeah, I'm just going to do it in here. Okay, just it's going to be some spaghetti, as I said, ass code. Okay, we're just going to do some ass code. We're going to write the status line. We're going to write some headers, but instead I'm going to go like this. Delete. I need the delete out content length, right? I'm going to have to set transfer encoding with chunked, right? There we go. So we're going to set the headers to have that. Let it just happen. We're going to just let it happen. Okay, I'm sorry. We're just going to do this. All right, so there we go. So we're going to have the content type text plain. We're going to do a little bit of text plain. Let's replace any of the content type, right? Content type as text plain, right? Because I don't know what's going to be coming out here. Chunked. Oh, we're going to chunk. It's only spaghetti if it comes from spaghetti region of France. Otherwise, it's sparkling dog shit. Brothers, we're going to write some sparkling dog shit. Okay? All right, here we go. Carmack eats pizza. I write spaghetti. All right, so this is how we're going to do this. Now, this is going to be a little bit goofy if you're ready for this one. So we're going to do chunked encoding. But how we're going to do this is I'm going to do the following if you're ready for this one. Response dot, is it body dot read, right? So I'm going to go like this. Data, actually, we'll just go like this. Data equals make byte. I'm just going to do this kind of inefficiently. That's fine, right? Here, we'll do it like Lane said. We'll do it 32 at a time. Very beautiful, right? We'll do that. There we go. We're going to read the data, and we're going to have n.er equals this. If does not equal nil, let's see, errors is io.eof. If that's the case, then we just simply break, right? And then I can write this niceness. If it's not that, what do we write? Now, you know what? I think we should just break either way. Because if there's an error for whatever reading, let's not even worry about that case. That case is insane anyways. Let's just write our final one, which is right body. It should just be a 0. I can't remember. Is it also registered nurses there? I can't remember if that's the case, right? There we go. So this makes sense. So yeah, you do /r/ends. Okay, so it's pretty straightforward. We're going to write the bytes, then we write the data, then we write the bytes, then we write the data, then we write the bytes, then we write the data, and then we do one empty line. Notice that, again, this is just like headers, right? This is just like headers. One empty line says, hey, we're done. End with a 0, end with an empty. Boom. We're good to go. We're off. We're done. So that's kind of like the final one. So if we do read this, then you know what we need to do? We need to write this thing out, right? So we need to write out two things. The first thing we need to write is actually we're going to first need to write the hex, right? So how do I do a hex? I can't even remember how to do a hex, right? In Golang, how do you get the, I think it's, what's it called? %x. If I'm not mistaken. How do you get the hex string value of a number without the leading 0x? I want to say I'm correct on it. I knew I was right. I just wanted to make sure, you know what I mean? So I'm going to go like this. I'm going to go format.sprintf. We're going to take this bad boy and we're going to go like this. %x /r/n. And there we go. And then we're going to take that one and we're going to pass it an n. Beautiful. Then we're going to take the data and we're going to write up to n. All right, there we go. Bada bam, bada bam. And then after that, we'll go in here and we'll write another /r/n, right? Just like the thing calls, right? This is actually so simple. Hopefully you can just see how easy it is to do chunked encoding back out. This is super easy chunked encoding, right? I literally get some data, write some data, get some data, write some data. It's like there's nothing to it. Now, long as I didn't do these things wrong, this should just all work out. And then, of course, we should make sure we return. Again, spaghetti code. Just let the spaghetti happen, okay? Hey, bros. Just a little spaghetti code, okay? Do a status line, make sure we have the proper headers, write out the headers, call it a day. Pretty straightforward stuff, right? So we have this bad boy. Whoa, my gosh. Oh, my gosh. All right, so I think this should just work. Hashtag that one, brother. You know what I mean? Hey, brother, hashtag that one. So let's see what happens here. Let's see this one. Okay. Dude, I literally don't even know what to expect on this one. Okay, true. I forgot that I did that. Okay. Oh, you're probably saying, well, there's a bunch of 20s there. That's not 32. And you know what I'd say? Hey, hold on. Hey, you, hold on. That's not what happened there. That's not what happened there. Were you not paying attention? It said hexadecimal, brother. And if you did not know, okay, that's way too big. That's way too big. Let's go like this. 0, hex, 2, 0 is the same thing as 0. Binary, 0, 0, 1, 0, underscore, 0, 0, 0, 0. Now, this is 1, 2, 4, 8, 16, 32. Bam. That means it only has 32, which means that's going to be 32 plus 0, 0, 0, 0, 0. So the answer is 32. 20 hex is 32 decimal. Get wrecked. All right, there we go. All right. You know what I'd just like to say? Chunked responsing. First try, not a big deal. You wouldn't get it. All right, chunked quids. What's wrong with this example? Here we go. 10. That should be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's 10. Obviously, that's wrong. 10 should be 8 because it needs to be hexadecimal. Yeah, that's true. Let's see, the message, it looks like it ends with a 0. The content length should be specified in the headers. It doesn't have content length. Not enough midi-chlorians. I do like that last one. That last one feels the most correct for me. Chunked quiz 2. Okay. What's wrong with this example? Let's see. Okay, hold on. Let me see if there's null. Should not be null at the end. Bam, bam. I got that one. All right, here we go. What's wrong with this example? No more after this, I promise. Let's see. All right. Let's see. Content type, text plain, transfer encoding, chunked. I thought this was Epstein did not kill himself. I just realized how very popular that is right now. Okay, well, what is they asking? Transfer encoding header should be live. What? Transfer, let's see, hold on. The first number should be 10, not 26. I don't want to have to count that much, but that looks way longer than 26. I don't want to have to count. Content type should be chunked. No, there's no content typed. Absolutely nothing. It's just like Star Wars Episode 3. Dude, I can't believe you made me agree to that, Lane. Lane, I can't. Dude, Lane, you should not. Okay, Lane, we don't need activism. Okay? There's no activism. There's no need to have activism here, okay? You made me agree that nothing was wrong with Star Wars 3 is insane. Absolutely unhinged behavior. How long have you been waiting, Lane? Do you think it was a bit odd that we had the right /n//n? Well, no, that's because that's a trailer, and the empty trailer signifies you're done reading trailers. Oh my gosh, it's like trailers are headers. Oh my goodness, trailers are headers. But to be completely fair, they should never have been called trailers. Okay? They should have never been called trailers. Okay, I want you to think about something. This is what happens. Okay? I want you to think about this. There's the status line, there's the headers, there's the body, and then there's the trailers. Now, if we were honest here, if this is the headers, these should be called the tailors. You know I'm right. You know I'm right. Footers, don't want to call them footers. No one likes footers, okay? Okay, it's entirely too close to soccer, but called with the British way, so I'm never going to say that. He's unstable? Oh, absolutely, I'm unstable. Well, I did. Why not just use one registered nurse? Was there a COVID outbreak on the HTTP spec? Got him. There's actually a good reason for it. It's because you can have an additional headers at the end of the chunked encoding called, of course, trailers. They work the same way that headers do. Okay, first off, I don't think I said that, Lane. I think you're putting that joke in my mouth. Okay, because I feel like I make better jokes than that. They work the same way as headers do with one catch. You have to specify the names of the trailers in the trailer header. Yes, if you don't know, which makes perfect sense, by the way. You cannot have trailers, because you could imagine, there's like trailer attacks is what they're called, where you can do like a small amount of chunked encoding and then you just constantly do trailers. And so you can do things that are like, I believe there's some sort of trailer attack that you got to be careful about, so you have to specify the trailers ahead of the time. Trailers are often used to send information about the message body that can't be known until the message body is fully sent. Like if you had some sort of calculation, if you had some sort of checksum, you could see this. For example, a hash of the body message body. In fact, let's do that. Let's add a new method to your response package that does what you would expect based on the knowledge of your trailers I've used. All right, trailers. Remember, the trailers are formatted just like headers. In your proxy handler in the HTTP bin, announce content or X content SHA-256, X content length as trailer header trailers, okay? Remove the content length header. We already do that. Keep track of the full response body as you read it in chunks from HTTP server. Okay, once you're done with that, chunks, calculate the hash SHA using this one. Okay, I've never done this before. Okay, that seems fun. And add these to the end. Run your server. Bada bing, bada boom. Okay, we can do that. Dude, I can do that. Dude, bro, I can do that. Watch this. You think I don't know how to do that? Right now, I'm not doing it the way you want me to do it, Lane, because I don't have to do nothing you tell me to do, okay? What's this one? Replace it with byte sprint F to... No, I'm not going to append it. Stop making me append things. Okay? Stop making me append things. I'm not going to do nothing, Lane. Okay? Okay, Lane? Okay? Hey, Lane, I'm not going to do that. Okay, Lane? Think about that. Let's see. Full body. Right. There we go. And I'm going to go like that. And then I'm going to go like this. Let's see. Full body equals... No. Can we append? Can I just append? Yeah, I guess I could just append and do ... Is it that? I could use that append operator, or is it the other way around? Hell yeah. I know this is super inefficient, but whatever, right? There we go. So we have the full body, right? So we're gonna trailer this bad boy out, but we're going to do some stuff. I'm going to also go like this. Set trailers. Trailers? Is that? Oh, no. I just got visual satiation. I can't remember how trailers are spelled. I literally cannot remember how trailers are spelled. Oh, my gosh. Okay, it's trailer. That's right. Okay, trailer. And then now I need to set, and I need to set in 2 trailers. I need to set in, where are we setting these things? X256 shop. Okay. Bam. Bam. And then we need to set in one more. What's the other one we're setting in? Content length. Oh, my gosh. It's like my API works. There we go. Awesome. So I got the trailers. Cheer these nuts. Okay, my cheering doesn't work. And Matthias, thank you very much for the tier 1. I appreciate that. Okay, buddy? I appreciate that. All right, so there we go. So now we have these 2. Fantastic. Which means now, afterwards, I can do all this. I can write all these bodies. And instead of writing this last one like this, I can go da-da-da-da-da. And then now, watch this one. Trailer equals, are you ready for this one? Headers, new headers. Headers are trailers. Yes! Headers are trailers! They're the same thing! They're field lines. Trailer dot... tailors. Tailors. All right, let's set, and let's go up here, and let's take... let's yank these 2. And let's go tailors. And let's set. And now I need to use this SHA business. I've never used this SHA. I've never used a SHA-256 sum. SHA-256, SHA sum 256. What is it expecting here? Bytes, full body. Let's go. Out equals this. What is this thing? Bytes. Okay, so how are you going to encode it? How do you plan on encoding this one? Okay. What's the encoding? Do you want me just to paste it? Okay, I think I know what the coding is. I know what you want me to do. Okay, I know what you want me to do. Func, two-stir, bytes, byte, string. We can just write this one. Out equals that. There you go. For don't worry, we got that. We'll just do our own quick one. Because it's not like you told me what to do with that one. Content length, let's go like this. Content length is equal to full body length. Okay, what's your problem? And then, of course, this is format sprint F0D. Wow. Wow, I just lost my brain completely there for a second. All right, what's your problem here? 32 byte does not have a... okay, okay, buddy. Got him. Slice it up. Slicing and dicing. All right, there we go. So we got that one. There we go. I know, we got it. That's not SHA-256. You're a SHA-256. There we go. Is that the one that wanted me to do? Sum 256. We're summing it up. We summed it up, boys. There we go. So now that should give us some nice trailers. So this one, let's see. Expecting status code 200. Expecting SHA-256 trailer contain. Expecting trailer length this. Okay. It's a very specific trailer length. Don't you need to, like... Don't you need to, like, first know? Wait, I'm confused. Is that right or wrong? Wait, did I fail or succeed? Did I fail or succeed? Okay, there we go. Let's see. Expected Shaw trailer to contain this, but it did not. Well, wait, what are you requesting? Oh. Oh, wait, that's a... Wait, what is this one? Wait, did I miss that? When did we agree to this format? When did we... We only agreed to stream earlier. Okay, that's my problem. Okay, hey, that's my problem. But why? Failed plus one. No, fail only counts as sections, okay? A slog, info, response. Oh, no, we can't do a length of the response. Let's see, let's HP bin, right? We're going to do that one, and let's go like this. Let's see what the target has to say it is, right? Target, and then we also have, which is that, and then we also have our which is going to be All right, let's see what happens here. All right, target is HTML. That seems good. Error is nil. Wait. I forgot to do that as the final thing, because remember, we have to do the whole, like... Oh, it already does it for us. Okay. Do you like how we have tailors as headers? Okay. Okay, so that's good. All that's good. Response trailers equals this. Okay, it almost said the same thing. How is there any chance that these things are that close to each other? Like, what are the chances that it's 3F, 3.2, almost that, 4? Okay, look, dude, the same one's right here, same one's right there. CF 82. Okay, it's not the same starting right there. Wow, it was the same. These are all the same. That's crazy. And then most of these are the same. They're missing a 0. Wait, how is that possible? Yeah, I know. That's why I said, how is that possible? What are the chances that it's that close? A new line should be a 0. I'm confused. Yeah. Returns the SHA-256 checksum of the data. Yeah, because that means the tiniest difference in data should effectively make a massive difference, right? Right? That should just, I mean, that should be effectively a completely different thing. Yeah, see, that makes it just virtually completely different. Okay. I'm gonna say I'm right on this one. Dude, I am just refusing to believe that somehow I'm getting a SHA that's almost exactly it, except for off by a couple numbers. Like, that's just not... It's probably the 2-string. Oh, it's probably the 2-string. Okay, it's probably the 2-string. Yeah, that's probably mean. I don't know, Prime. Okay, that's my 2-string. Okay, that's probably... Okay, fair. Hey, guys, fair. Okay, that's a fairing. You're fairing out right now. Okay, you're fairing me out. You're right. Is it that? Skill issues. All right, let's see, as we've covered, HTTP is a plain text protocol, but that doesn't mean that you can't send binary data. In fact, HTTP is quite good at sending binary data, and it does by using the content type header that indicate the type of data being sent. For example, if you're sending an image, you might want to use content type image/PNG, and if you're sending a video, you might want to use content type video/MP4. That way, the client knows how to interpret the body. Rather than reading it as raw text, it can expect a specific format of video data. Assignment. The beauty of our current abstraction is that we have all the tools we need to respond with binary data. Let's add a handler that responds to a video. Curl to download this video. All right. Add a new handler for get video endpoint that uses content type MP4. I use read file to just read the whole file into memory. Probably not the most efficient, but works for our demo. Yep. Then navigate to this in your browser. Does it work? Pretty cool, right? That stuff's not so scary. Okay, so this is going to be using a MIME type, right? So we're going to be using the content type, that right there. So let's go like this. Do you like all these if else's going on? If only there was something that allowed you to do checking on a per file basis or on a per path basis. If only we had something called like a handler or something. All right, so let's go like this. equals os dot read file, and let's go like this. Assets dot. Yeah, there we go. Dude, Lane, what have you done to me, by the way? I'm just going to assume, by the way, I'm correct, okay? I'm going to assume I am the correctest of the most correcticus, okay? Replace this one, go here, and we're going to go video.mp4. There we go, right? That's the MIME type. Yeah, that's right. It's a video MP4, okay? And so we're going to we're going to do all this stuff, and so then we're going to take this thing, and we're going to go write status line. You like that? I like that. Okay, we're going to do those things. We're going to do all this stuff. We're going to grab all these things. We're going to grab this. We're going to write status line. We're going to w.write headers. Let's go. Headers. We're going to write out those headers. Is everybody ready for this? And then I think we should just be able to go, oh, I can't access the underlying body. It would be so sweet if I could access the underlying body and just do writer to writer, but fine, that's fine. Write body F, right? And then I should probably go like this. Let's go headers.replace.content length with, let's see, format.sprint F %D, and that's going to be length F. F's in the chat, boys. F in the chat. There we go. We're going to replace those ones. There we are. And so let's see if this actually works. Okay. Bam. Hit that bad boy. Let's go to localhost 42069/video. Whoa, it worked. We're not going to watch me. We're not going to watch me. Okay. But that worked. All right, nice. Watch it. No, of course not. Yeah, right. Yeah, right. Boom. Yeah, right. First try. All right, HB tip. First of all, great job. You've made it through the TCP to HB course. My goal at the course is to dispel magic, not the magic of discovering something new and the enjoyment of new technology or programming language, but the ability to see a problem from a new angle. No magic that makes you feel, no magic that makes you feel like you might not be capable enough. You are capable. That's right. Problem is that I can't tell you how many people think that this stuff is like actually magic, like writing these things is actually magic. It's not actually magic. It's just really simple parsing and just following a guide. That's all it is. Oh, you want to know how HB works? Just read the RFC, do it step by step. It's really not that crazy. It truly is not that crazy. That said, you learned a whole lot about HTTP 1.1, but I don't remiss if I didn't leave you with a brief teaser of HTTP 2 and 3 because you'll see them around and they're very different from HTTP 1.1. Well, actually, they're not that much different. They're only different on the wire. However, it's notable that a lot of the internet still runs on 1.1. Yeah, it's shocking how much still does. It's a binary protocol rather than text-based. So HTTP 2 is pretty cool. HTTP 2 is really simple to understand. It runs on TCP. It just makes it's just really easy to understand. That makes it more efficient and less error prone, but also requires more steps to debug typically. Yep, HTTP 2 uses multiplexing, yep, which allows multiple requests and responses to be sent over a single connection at the same time. This reduces latency and improves performance. Uses header compression. This is called HPAC. It's pretty cool if you don't know about HPAC. HPAC is like the good stuff, right? HPAC. There we go. HPAC. That's where you want to be. You want to be on the HPAC business. HPAC is pretty sweet. It's considered the silent killer feature of HTTP 2. Header compression, allows for server push, which honestly, this is insane. I don't know anyone that got server push correct, right? Server push is just an insane mechanic. Built on QUIC instead of TCP. QUIC is a transport layer protocol that runs over UDP. Effectively, people just call it TCP over UDP, but though I don't believe it's quite the same, which allows for faster connection establishment, improved performance, mandates encryption at the HTTP protocol level. HTTP 1.1 is unencrypted by default, which requires HTTPS to be secure. There's also some interesting stuff. HTTP does leak some stuff, right? Not every part of HTTP can be secure, right? When you're doing like DNS. DNS is still not quite there. You have to do secure DNS. All right, there we go. I'm done with this step. Yes, there's a lot more. HTTP is great. There we go. Boom, claim it. We're claiming over 5,000. Boom. Wow, look at all of those. Yes. There you go. There you go. There's your free walkthrough, everybody. Hey, you better thank Lane because Lane allows this course to be done online and free on the internet.